Right. Hi. Going back to working on kast today. Let's see. Let's see. Just my tests are all working. Last time I was doing things. The tests are working, but there were some things that were not working, right? It's gas time. Get my long grab your grabs. Yep. All right. What am I going to do today? So there are options. There are options. I could do like the context system, or I could do this other system that I was thinking about since last time. Last time we were trying to do this like monad stuff and everything. I think it's not even the monad stuff. Hold on. It's just like if I go to the REPL, I think there is like this problem basically where if I have a unit and it's a unit value of type unit, right? But I have a unit as a type, this should be a type unit, which is a different than the value unit, right? It's I think it's mostly just about the tuples. So like a unit is just an empty tuple, kinda, right? I have it specialized as a unit, but I mean the tuples are the same. If I have a tuple of an int and a string, then it's not a type. It's a value of two types. But if what I want to do is I want this to be able to be a type, right? So this does not work because I expected to have a tuple of two types, but I got just a type here on the type description side, right? What we do instead is we do right now is using the cast operation. This also does not work actually because not in third type cannot be hashed. For some reason, Gina the potato, hello, hello. But I don't even want to write the cast operation. I think it's just should be like done like this. So in languages like Rust, or in most languages, I guess, the syntax, there is in the syntax specific nodes that represent types and specific nodes that represent values, so that you can know if this should be a type or a value based on like where it is, right? Yeah. But like, let's say that I have something like this, right? This is type description. Heavy Y with the waste your points option. Nice. Also, I'm just realizing that there are no crabs. Let's do restart all my bots because Twitch breaks all the time. I'm going to do this. There you go. What's up tonight? I'm making a programming language. So I'm just going to make progress on that project. Right? So yeah, there is this thing where there are certain things that can be both values and types, which is tuples, including an empty tuple, which is a unit, right? I was saying already. And like std in 32, std string. This right now is a value of two types, which is, and the type of this value is the tuple of two types, right? Is 5 a type? I actually don't know. Like maybe it is. Like it can be a type, I think. Like, you know how in TypeScript you can specify your values in your types, right? Is there a TypeScript playground? Hi. I think 5 can be like done as a type. Can I just run something? Logs. Hello, Daniel Pancake. Right? So like you can have in your TypeScript code like this where name. So these are normal types, right? String, number, boolean, right? But you can also say that name is not just a string. What the hell? This website is trash. You can say that name is name. You know, you can have a concrete, and items can be 5, right? You can do this. What would that mean? Right? So in TypeScript, it means that the only correct value of this type is where the items field is equal to 5, right? And where the name is equal to name. This is kind of how they do like tagged unions and shit. You know? Because when you say like if so like if you say what like let t is like I can have another interface here, right, where name would be like something else, right? So I don't know, something else, right? So I can have a value foo, which is type app configuration or something else, right? And since I know that this is it, I can now distinguish this by saying if foo name is equal to name. This is basically like checking the tag of a tagged union, right? Then I know. I don't know how you do it undefined. You cannot do undefined here, right? So I need to like say name is something else, right? I think because I have assigned it here, like it already knows that the name is not name for sure. Which means that foo is always just something else, no? The comparison appeared to be unintentional because of the type something else and name have no overlap. We call that type narrowing. Yeah. Type narrowing is what they call it. So like, but does it make sense in like a compiled language? The type is still like the actual type is still string, yeah. But it's not like the actual type is not string. It's a string that like can only be a concrete value, right? It's like in Rust you have like an integer or you have like a non-zero integer. Those are technically different types, right? You have a pointer or you have a box. Box is like a pretty concrete pointer, kind of like refined types, maybe. Hmm. So it's different when I have like a value which is a tuple of two types. This as a type. Well, I mean, actually, I think this is actually very similar. Hmm. But I don't think I should implement it the same way. Um, First of all, why does this not work? This is panicking because not in first type cannot be cached. But what is not inferred here? Everything is inferred, right? Is the thing. I need to make sure to see where. Where the Alps hash is. Error message is worse than Haskell. Well, I mean, I did panic here because I'm using the standard hash implementation. This does not allow me to have the like error as the result type, right? This is not returning a result. This is just returning. This is just doing the hashing. So if there's something that cannot be hashed, I'm supposed to like not. I don't know. I guess we just do a different trait. But then I need to write my own derive macro to make it easier and shit. Other option would be to catch this panic, right? Whenever I'm using the hash. Let's try to make a derive macro here so that like the error message is better because yeah, why not? Let's have a new like thing that is going to be called try hash, right? Is there such a thing? Hold on, docs try hash. Imagine if such a crate already exists. Crates IO. I don't know, libs rs. Lib rs. Hash by. And try hash. F try hash. I think that thing does not exist, so I'm going to do that. Great. Try hash. Argotoml. Let's see here. Try hash. Dependencies is going to be try hash derive. Path is derive. Going to also have source librs, and I'm going to have derive argotoml here. By hash derive source librs. Proc macro true. Is that what we do? I don't remember. Cargo test. Argotoml. Let's add try hash workspace true. Try hash path creates try hash. Okay, cargo test. Okay, now it's compiling it. All right, let's see the try hash itself. I'm going to have a trait try hash, right? Which is going to have as function hash itself into a hasher, which is mute std hash hasher. Wait a second. Let's see, impl std impl try hash for everything, which implements std hash, right? Std hash as has function hash, where hasher is actually generic. Okay. Mute. I guess simple std hash hasher. That's how I do it. Or make it a generic argument, it doesn't matter, I guess. You've been doing too much of that lately, the procedural macros. Which crates do you use? Let's see, which crates am I going to use? I'm going to use sin. I'm going to use a quote. But probably that's it for this crate, because I don't need to like customize the thing. But if I was to like parse the attributes, then also I use darling crate to parse the attributes. Darling and proc macro. Yeah, okay, so you should use the same shit. Proc macro 2 probably also needs to be there, yeah. Going to have these in workspace dependencies. Probably, maybe not. And let's see what's the versions. Sin version 2. Quote version 1. Macro 2. Is version 1. Import sin from darling. Yeah, if I use darling, I guess I don't really need darling here though. There are also technically like more lightweight alternatives to this. I know if my deriver is really simple, but I guess I don't care here. Cargo test. We do proc macro derive. I'm going to derive try hash, right? Public function derive try hash. These things take as input. Proc macro. Do I need the extern create proc macro here? Macro token. The token stream. It is token stream. Okay. This should return proc macro token stream. 574CY. Hello, hello. They weren't enough for you or something. Yeah, probably not enough for you. You're doing like a lot of things. They would probably be enough for me here though. But I don't know, like everything there depends on sin and quote anyway, so like why would I like adding more lightweight dependencies is just like adding more dependencies. Then no. I don't know. Proc macro derive attribute is only usable with crates of the proc macro crate type. Crate type. How do I do crate type? I forgot about that. Is that not the correct crate type? Is proc macro? Fast proc macro. Lib proc macro true. Not package. Alright, so then we do sin derive sin. No, you don't want to be sin? Okay, sure. Let me close this everything. Save changes. Yes. Reload. Derive. I have this here. Sin. Yeah, okay, now I have sin. Sin derive input. Is input is sin bars. Parse input. Right. Actual value found in derive input. Colon. Parse macro input. There is no such thing. Parse macro input. Parse the input token stream of macro triggering a compile error and the token is failed to parse. Isn't that the same thing though? Oh, but there is my macro input, so you can have my macro input as a struct. Oh, okay. But then you just implement parse for it. And you implement parse by just, so like, it doesn't just do parse and then unwrap? Isn't that all that it's doing? Yeah, we literally just parse. Well, I guess the compile error is what they do. Like they map the error to be like better compile error, I guess. So I don't need to unwrap here anymore. It's the same thing. All right. Okay. Input generics. Split for impl. Impl generics. Type generics. And where clause. Right? We do this. We return something like quote. And then dot into. Is that all I do? Quote. Use quote. Okay. So we do implement. Okay. What's the modern way of doing the thing, or is it still the same? Like I don't have crate in this. And proc macros. What are you doing? You're just hard coding the name and hoping that it's in the scope. Try hash or name. Its name is, I guess, ident. It's input.ident. You do colon stacks. This means that you need to like have the stacks as your like crate, and it should not be renamed. So it should not be like imported from other crate. It should be direct dependency of your crate, right? I think personally I prefer this to be like in scope somehow, like try hash like this without the colon. So that I can like re-export it and it would still work. Impl generics. Try hash for ident type generics where clause. And then we do function try hash. This function is also wrong. This should be a result. What would be like the error? Should I have the error type here? I guess I should have the error type. What would be the error type if I derive though? Then the error types everywhere should be the same. Let's see. Also, like for everything that is represents the standard hash, the error would be what? We could do boxed in std error. So the implementation here is just t as std hash self. We need anonymous A or B types. Yeah. We have that in TypeScript too. We kind of have that in kast already. I actually don't have named types yet. Self and sure. Then I say okay. All right, let's see here in the derive now. Type error would be equal to the box then std error. I think I just do the same thing here now. So when I derive, I go over the fields, right? I also okay. So I just need to like copy paste whatever the Rust hash derive is doing, which is doing the discriminant. I also don't have completion here. Std discriminant. No. Docs rs std. It's score intristics in discriminant or something. Std mem discriminant. Returns a value uniquely identifying the enum variant in V. If this is not an enum, this will not result in identifier, but the return value is unspecified. So we can always do the discriminant even if we don't have like the fields. I guess. Chunky lover, hello, hello. Std mem discriminant self into hasher. I need to see input dot to how do you do this again? Docs. Let's just see docs for sin. Sure. Example of a derived macro. Expanded Spanzer reporting, parsing a custom syntax, optional features. Derive input is data, and data is a struct, an enum, or a union. Yeah, there you go. So I'm going to maybe I'm going to just match. Input dot data. How about that? Union panic union no support. Okay, let's do the struct first. Okay, the macros are not formatted, right? Hello? All right, like this. So in this case, I don't do the discriminant. I'm going to have that only here. Right. Here I don't need discriminant. I just go over the fields. Struct has struct data. I guess I will need to more stuff here. Data dot fields dot I guess just data fields. These fields, and then here I do something like self dot field without the hashtag here dot say std hash no not std actually, right? I do want to use the try hash here. Try hash. Let me do this. Try hash is this. So I use the same thing everywhere. So I'd say try hash self field question mark semicolon star return okay in the end, right? That's all I need. So field fields need to be then iterate map field ident is optional. Which means I need to iterate and enumerate into map field dot index and field match field ident that is some ident. Then I say that it is ident. If it's none, then I need to do sin the index of a named tuple struct field, right? This thing, index. Is there a new thing here? No, there is not. We just constructed index span field dot span like that. You can convert to usize to u32 index as u32. I don't know how to like make this nicer. Is there a way to do this nicer? Because in order to refer to a field, I either refer to it by its identifier or by its index. It's a lot of code to do this simple stuff, though. Suyash, hello. I'm doing great. I'm just doing a little bit of procedural macrosing in Rust. So, and then if this is enum data, then I should say variance is data dot variance dot iterate map variant dot. Okay, so I need to like do the variance, right? So over here, what's going to actually happen is I'm going to match self, right? And then I'm going to iterate over the variance. So each variant should be like the implementation of me hashing the variant, right? Like this. Will return okay in the end. Okay, so variant. This is going to be name is variant dot, I guess, ident. I'm going to return quote if we have self colon colon ident, then we are going to need to do the fields here, right? So this is now going to be the same, and also over here, not to match self ident, I need to match with the fields, right? Fields. Fields, comma star, right? So then I just do the same thing where I actually do the fields here. So in this case, I'm assigning the fields to the new variables. Like that. Cannot find fields. Data fields is just fields. Over here we have the variant dot fields, which is also fields, right? Let's have fields, which is fields. Is going to do something like that. Fields is fields with data fields. This case, and fields is fields for variant fields in this case. Mismatch types expected has iterator found. There is no iterator in repetition. Amazing error message. The fields is sin fields, right? Mismatch type expected has iterator found. There is no iterator in repetition. Over here, hashtag. Okay, and then move occurs because this needs to be clonable. So because I'm doing the repetition here twice, because this is not clonable, right? Because of that, I need to have fields and fields too, so that it does not get moved. You want to make a tic-tac-toe game and a whole AI thing with kast? But be patient because this is not a simple project. Expected function found map. Yeah, because okay. Fields 1 and fields 2. Maybe scene can work with actually clonable things. Hold on, maybe it's because it cannot be moved. Oh. Oops, sorry. But if I return a vec here and then I would collect it here, does it still going to complain that it's moved? So like I think there is like a special like implementation in the quote crate where the thing that you're iterating over is not an iterator but a vec, then it would like clone it automatically or iterate over it without moving out, I think. So yeah, that means that I don't need to have field 2. Okay. I think that's the entire derive macro here. Jenny and Dos, hello, hello. Okay, should I have a test for this? Since this is basically a standalone thing. Let's have tests here. Tests. Okay. Also, I need from here to re-export pub use try hash derives try hash, right? Like this. So what I can do in a test, I can have a struct who, which is like a I32 b I64. I can derive try hash here, right? No function of the associated type error, and try hash must be the value of the associated type error must be specified. So I did not do the error. Type error should be okay. Boxed in std error. I'll start with that. Could you explain the purpose of this? Can it fail and why? The hashing. Well, I want to it's like a dynamic trait, I guess. It's either implemented or not, kind of thing, right? Because I'm writing an interpreter, and in the interpreter I have something. I have a value which sometimes can be hashed and sometimes cannot be hashed, you know? But yeah. Does it make sense? I think that's the entire thing. You're lang deving and people asked whether you're reinventing TypeScript. Are you reinventing TypeScript? You know, I'm experienced full stack dev, but a week ago my dad asked me to make a website for him and I don't know where to start. Like, what the fuck? All right. But yeah, so the thing is with this and why this can fail, because I mean, I could do it like in the other way instead of like implementing hash directly. Like I basically have inferred types and not inferred types, right? And whenever I want to like hash something, I need to make sure that it's an inferred type, fully inferred type, right? Maybe I could, instead of making the like the hash fail when something is not inferred, I could instead have a different type. Maybe that would make more sense over here. So we have an inferred type, and I have a so the inferred type is like the inferred like overall structure of this current type, but inside of this type it can also contain the types that are not necessarily inferred, if that makes sense, right? So if you have, so like when you have a type, it's either completely uninferred, or we know that it is a tuple, for example, of two nested types. Those two nested types are not necessarily inferred, but are like It's either I know the overall structure or not, basically here, right? But when I want to do something like a cast operation, I need to know the precise type. So everything must be inferred in that point, right? So I did that by saying that not inferred types cannot be hashed, basically, right? But I could instead say that I should introduce a new type, which only contains the fully inferred things, and then I would like check for that first before hashing that, and then I don't need to like have my try hash thing, right? But that means that these inferred types need to be a generic, right? What's the inner type, right? So this, instead of the type, I would use inner type. Everything becomes generic now, because it's either a type that potentially is not inferred, or it is inferred. It complicates things, but I mean, technically that's what I would need to do, right? I don't know. I think for now I will keep the try hash. I think for now I will do the try hash and just do this panic. Right? So instead of panic, it will just like be a result now. Maybe I will end up not using it eventually. We'll see. That's too much typing. I mean, the typing only happens on the type definition. When I'm using the type, I would not need to type the generic arguments to it. No function of this is, or the value of the associated type error must be specified. Hello? Cargo test package try hash. Create objects must include the din keyword. Did I not say the box din std error? I did say that. Oh wait, hold on. This is completely unnecessary, I see. Box din error, yeah. The value of the associated type error in type hash must be specified. Isn't this the thing? That I'm doing? I'm doing a struct, so like this is the only thing that matters actually. No function or associated item named try hash found for trait try hash. Okay, because I actually called it hash and not try hash. Missing try hash in implementation. Function try hash. Function try hash. Okay, argument number 2 of type mutable underscore is missing. Okay, yeah, because try hash into a hasher. Of course. Hash fields, hasher. Rust macros are fun, yeah. There you go. The test works. And then we also want this to be derive try hash. Try hash. This also should work for enums. Enum foo. So I can do A, I can do B, I32, I can do C containing the, okay, foo enum. This is foo struct. C can contain foo, which is foo. Right, and like no, I don't know, string, right? Okay, so now Not all traits are implemented. Missing try hash. Are you... So here's the problem that I don't like. They say tuple variant will be written as struct variant. I thought this was supposed to work though. No? If I go to the playground, if I have struct foo, and then I have I32, right? Can I not have function foo? Foo is foo. I can match foo with foo, where field number 0 is 1 and field number 1 is 2. Can I do that? So like I can't do that, right? But why does it complain when I do it with enums? Does that not work with enums? Enum foo a? Foo a? Like, does that not work with enums? Enum declaration, semicolon, not needed. No, this works. Okay, so that's not the error. Why do I have the error then? You have a question about my language? Why did I choose to throw errors instead of errors as value? Because I think it's easier to work with. Have you tried? Okay, so like I will have both ways basically is what I'm saying. It's just like working with the result type is nice when it's just a single function, but like when you are nesting results, async, and a bunch of other things together, it becomes pain. Okay. Go air is easier. No, I think go air is harder. I mean, I guess like what I'm doing is closer if you're talking about like those languages to the Zig error handling, which is very similar to result, but you don't need to wrap your like success values in an OK, right? It's very similar to throwing. It's I mean the most closest thing I guess is Java's checked exceptions. But do they have an example here with failing? But goes error is a horrible thing. I don't want that. No. What was I trying to look for? Documentation. This is also very similar. So like this is just like a Rust enum basically, right? But like unlike Go, where your function can return both an error and a success value at the same time, you're actually supposed to have only one of those two, right? That's the easy way. Like only one of those two things is actually like happening. It's either a success or a value. So in Rust you have a result type, or in where's the actual example though? Like this over here, exclamation mark. Exclamation mark means that we technically return a U64, but exclamation mark means that it can fail. It in this case is automatically inferring the different types of errors that can be returned here, right? But this is very similar to throwing an exception. It's just like it's using a different keyword, but it doesn't mean that it's something else. It's also is throwing exceptions, and it also is like checked exceptions here that you have to handle, like in Java when you're using checked exceptions. I'm going to have something similar. In Zig it's same, but it is built in. Yeah. I mean, the error handling is built in. You can define your own errors, I think, right? Would this cause errors to blow up like JavaScript? No, JavaScript has unchecked exceptions, which is completely different. Unchecked exceptions is bad, just like anything that is unchecked is bad. Unchecked exception is same as like unchecked types in general. Yeah, like it's not much different from like I mean even Go's way of like having like error as an additional thing to return. It's not much different. It's just like Go makes it very easy to like forget to handle the error, right? We may need to make it hard. Writing bad code is supposed to be like writing incorrect code is supposed to be like not easy thing to do. You shouldn't be able to forget to handle your errors, which is something that you can do in JavaScript, and it's something that you can do in Go. But you cannot do it in Rust or in Zig or in Java, unless you use unchecked exceptions in Java. What's the error here? Function hash is not a member of try hash. Hash. Use std hash dot hash. Yeah, dot hash over here. I guess this is the problem. Std hash std discriminant self. Right. Did that make sense, or do you still have questions? What are the languages that are used to? I mean, since you said that Go's error is easier, maybe we are going to to disagree on a lot of things, because I think Go is the hard language. I think the simplicity of the language is not how simple it is to learn the language, but how easy it is to use it, which is a completely different thing. Full not found in this scope. Cannot find. Okay, full struct. Oh, throwing is error handling. You write exception handlers like Java or what? Yeah, kind of similar to that. Also, like, I will have the thing that is similar to Rust. I don't know if you're familiar with Rust. There is in Rust this unstable syntax, Rust try expression, right? So in Rust, in order to throw an exception, you do a question mark. You know, it's a different thing, but technically it's also throwing things. You know. And then you have a try block, which converts this entire block into a result value, right? So sometimes you want to work with the result enums directly, so you want to be able to convert your throwing code into a result. Sometimes you want to catch exceptions, like in Java. Yeah. If you look at Zig once again, Zig does it the same way, where you have something like, where is it, catch? Over here. So like this parse uint64 is a thing that can throw an exception, and they call it errors, right? We can call it whatever we want, but like you need to handle your errors. It's the same way, yeah. In Rust, instead of catch, you write something like unwrap or else, for example. It's called differently, but it's kind of the same thing. In Go language, you say if error is not nil, which is like doing it differently, but it still is catching an error. It's like a different syntax almost for the same thing. Yeah, try block is unstable. You cannot use it in stable Rust, which is why you probably never used it. But yeah, map error, question mark. Question mark is just a rethrow in an error, basically. Map error is almost like catch and then throw inside a catch block. Right? Actually, if we talk about exceptions, so like there is this common like thing where people say that exceptions are bad, but is that actually true? Because I was trying to look it up, why exceptions are bad, and I have not found a single thing. People just say that exceptions are bad, but why? And I mean, I agree that unchecked exceptions are bad, but what about checked exceptions? Anyone thinks that those are bad? Ones that break control flow, but isn't like async await also breaking control flow? Because it's like I guess like I saw this thing where people say that exceptions is like non-local control flow, but async await is literally the same thing, right? You're jumping out of a function, then you are going to jump back in. Isn't that also weird? Try catch syntax is ugly. Okay, ugly syntax I can agree with that, but syntax doesn't like matter too much though. I think the actual problem is unchecked exceptions, because like how easy it is to forget to handle them. That's the real problem. And that's why like Zig does Zig thing, and like why in Rust people like using the result types, because that's the alternative. But there are other alternatives, right? Exceptions are go-to with extra step. Yeah, but is that a bad thing? Everything is a go-to with extra step. Calling a function is a go-to with extra step. Exception means you're working instead of an either exception type monad. Yeah. But like, I mean, if you're talking about Haskell specifically, in Haskell also exceptions are unchecked. You cannot say, like, everything can throw an exception in Haskell. Similarly to how in Rust, everything can panic. So in Rust, the alternative of exceptions are actually like the panics, I guess. The alternative of unchecked exceptions are panics. And the alternative of checked exceptions are the result types. In Haskell, there is the either monad, and then there is exceptions, which is checked and unchecked things. Similarly. This error messages that I have here is very, very bad. Argument number 2 is missing. Okay, maybe I should comment this thing first. It's just the first one. Okay, actually, this works, but the errors are still shown to me. Amazing. LSP restart, maybe? I don't know. The language server is broken. Let me reload. Broke recently for you as well. I think it usually it breaks when I'm introducing new crates into the workspace, and I don't know, something weird is happening because of that. Expected 2 arguments. Okay, let's comment this variant. The function expected 2 arguments found 1. So somewhere in the derive of the enum, I only had 1 variant because hash discriminant. Okay, of this one. This one requires a hasher. And the try hash. Argo test. Okay, so you see how like my test actually compiles, my language server is still doesn't know that this compiles. It still is broken, the language server. What's wrong? Or is it Clippy? That is, no, hold on. Expect to argument for 1. That's the error that I just fixed. I think it's, is it like caching the result of the derive macro? Is that what happened? Cargo clean package try hash derive, maybe? What if I clean it here? LSP doesn't like updating derive macros? Yeah, maybe. Like, it literally is still the same. Okay, sure. I'm pretty sure that when I was working with VS Code, I did not have that problem. Does VS Code do something something here? Let's try VS Coding here a little bit. It's weird. Source, crates, try hash, tests. Okay, so let's reintroduce the error that I just had. Right, which is this should not have the hasher, right? Which means that this is not going to compile now. So this is the same error, 2 arguments, but 1 was supplied. Then what I went and what I did is I just added the, I just fixed the error, right? I had the hasher here as the second argument. Then I go back and this now compiles. What does VS Code do differently than the NeoVim? That's not the first time I see that VS Code works better than NeoVim, but I don't know why. Different LSP client implementations, like so the NeoVim client is wrong, right? Why is this a client thing? Isn't this a server thing though? Why would this be depend on the client implementation? This should depend on the server, no? Me handling the things. Maybe it's I don't know. I just don't know what's the difference here. Right. I guess I'll keep doing this. For now, tuple variant, self B written as struct variant. Yeah, but how is that an error? Consider borrowing here. I mean, it's the same server, so it's a client issue. Yeah, I mean, maybe, but why would it be a client issue? Like, I just don't understand. Why would it be a client issue? Is it the client that is caching the errors of the derive macros and then still showing me the error that doesn't actually exist? Is that what's happening? I thought the client should be like very, very small thing that shouldn't even have that logic. What's the issue here? So over here, self, ident of the variant, and then fields. And what's the problem? Can I have generate trait impl? Convert to manual. I really wish there was like the code action to expand the macro. I know that we can expand the macro by doing something else. Cargo expand. You can match tuple variants with this? Yes, you can. I literally just tried it on the playground. Here's how you do it. You can match and you can place, instead of the names of the fields, you can put the index to the field. That has been there forever in Rust. So here's what it's doing. Type error is this, try hash self b 0. Okay, I understand now why. Okay, I see it. Okay. So the difference between the named fields and unnamed fields is because for named field you can omit the name is if it's equal to the value, right? So you can say just the name there, but for this one I should say 0 and then I should still bind it to a name. But how do I do it then? Should I come up with a fake name then when doing this? How would how does it implement this for something like standard hash? Ident underscore ident. Underscore ident would not work because it would be like the quote would have it as two separate tokens, I'm pretty sure. So I need to combine. I need to like construct a new identifier for every field. So I can do self.0, but for an enum, I cannot do like self.0, right? So I need to match, and then I need to assign these to variables. I'm wondering how the how this works in. Let's derive a normal hash. The hash. So in the standard hash, okay, underscore underscore self underscore 0. There you go. Okay, so they do generate a new name for everything. Okay, that's annoying. Sure. Wait, can you do a row identifier in Rust? Can you do a row identifier r hashtag 0? Does that work? Found invalid character only hashtag is allowed in raw string delimitation 0. The row identifiers in Rust also suck. Okay. You did it with format? Alright. Let's see. So fields is going to be... alright. So this means that I need to have a struct field, which is going to be like the name. Name. What is the result of this? Token stream from proc macro 2. And then new name is a token stream. Right? Because 0 is not a valid name. 0 is a valid name originally, but not anymore. Right? So this over here is the actual name. Right? Field. The actual name is this. But then the new name, I guess I'm also judging by the implementation of the std hash macro, they do like the indexing even for the named field, right? So we can do the same. That's easy. Just say sin identifier new row, new row. I guess it doesn't matter. I just say new format underscore self underscore index. Span is field span, right? I guess this one is going to be sin ident now. The original one does not need to be an identifier. Is there an a thing in sin which is either an identifier or an index for the field thing? Maybe. Sin field so that I don't store the just any token stream. Pretty sure there is something like that. Docs sin field expression field base member. Oh, it's called member. There you go, member. So member is either a named member or an unnamed member, right? So this is supposed to be sin member. So sin member named ident sin member. I'm now used to the Vim keybinds. Unnamed. Right? So field does not implement to token, so now I need to have for struct, I just have field the names. This is totally fine. So I do fields dot iterate dot map field name, right? Field names. What extension I use for that cool typing effect? It's called the power mode. Power mode over here. Wait, what? Why is it not here? Power. Oh, it's with a space. Power mode. No. It does the screen shake, particles, and the combo counter. I customized it a little bit. Two tokens is not satisfied. So now when I do the enum field names and field new names is different thing, right? I probably don't need to iterate here actually. I feel like this can just return the iterator now. That's fine. Map field name and field new names is fields map field new name, right? So when I am doing this here, I am having the field names and I'm assigning the field name to a field new name and I'm using that new name here, right? There we go. Oh, now it's actually moved. Okay. Because I'm using this thing twice. Collect. Sure. And also the fact that this is not being formatted is also really annoying. When I'm writing derive macros, it never wants to format itself. This is not even this part is not even inside a macro. Why does this not get formatted? I have no idea. Lifetimes may not live long enough. Function, fields, simple iterator, item is field, plus a lifetime. You happy now? Okay. Cargo test. Conflicting implementation of try hash. Yeah, because I need not to implement hash anymore. Expected a reference to unknown found I32. So I guess the language server doesn't really work well in VS Code either, because like I don't have an error and it actually is here. Unless this problem is from Clippy for some reason, maybe. Cargo Clippy. Try hash. Tests. There is no error. It's still showing me the error that doesn't exist. Alright. Okay, well I guess we can go back to the new Vim now. It doesn't matter. Everything, nothing works properly. So it doesn't matter what I use. Okay. I can allow that code for tests here, it's fine. Alright, in derive, I have proc macro token stream is not being used. Semicolon is unused. That's the same error. Okay, sure. Okay, nice. And now we can go back to actually working on the project. Try hash. Okay. So now we do what? We do source type. So instead of deriving hash here, I will derive try hash, right? I'll just use here try hash, right? And well, I mean, yeah, I derive try hash. And instead of implementing a hash here, I implement try hash. Type error is can I use IRI report here instead of errors? Function try hash. So this should be match self. It's hello. Can my Rust analyzer give me the code action of filling the match like branches? Where is it? Where's my code action? Why is my Rust analyzer not working today, guys? I have no idea. It was working fine before. I think like at some point when the project becomes big enough, Rust analyzer just breaks. Okay, it's because there is no branches here. Okay, fine. Maybe that's correct then. Self inferred. Right, it's either okay or error. In this case, I reveal. Not inferred. Type is not inferred. Fail to hash. Something like that. Okay, type. Then you do type try hash. Sure. Question mark. Okay. The size of value for din size. Okay, so now because I use the box din as the error, this doesn't work with IRE reports, right? Unwrap or else error IRE e question mark. No? No, this should be map error. IRE kinds exists for reference box din error. Yo, Evan MMO. Thanks for the raid. How are you doing? Is your MMO done? Big streamer? Yeah, finally rated by a big streamer. Now I'm going to become a big streamer too. Oh, nice. Nice. Thank you for the help, Evan. What should I do now? Should I drop everything that I'm doing and I don't know. Review down some TikToks? I don't know. What do big streamers do on their stream? Become a variety streamer. Okay, hold on. Nerdsel, how do I convert a boxed in error into an IRE? I thought this was the way, right? Because this is a boxed in error. I need to convert that into the IRE report. Pretty sure. That's how I did it before. At least that's how I did it with anyhow. IRE works like that or not? Box in error. I cannot even find it here. IRE. This evaluates to a report. You can take either a string or a format with arguments. And you can also take any custom type which implements debug and display. Alright, doesn't boxed in error implement debug and display? Maybe not. So with anyhow, I think it's like this macro that was allowed to do the maybe wrap error. Is the wrap error method? No, this is just context from anyhow, right? Context compat. When porting from anyhow, okay. Maybe they don't do that in IRE. There's no way they don't do it. So, I mean, they forked from anyhow a long time ago. Maybe before anyhow implemented that thing. Boxed in error. IRE into boxed in std error. So this is boxed in std error. Oh, I need to do boxed in std error plus send plus sync. That's what I need to do, right? Just std error is not enough. Is that correct? So I need in my derive macro to say boxed in std error plus send plus sync. Do I do the same here? Can I have the error as being like nothing? Because in this case, there is no error actually. Okay, this is no longer a problem. Okay, so variant type, this is going to derive try hash. Trade bound try hash is not satisfied. Train found type is hash is not satisfied. Yeah, okay. Because box type, so like now I need to like implement my own like try hash for like boxes and for options too, right? Of course, of course. Impl t try hash for box t. Type error is t as t error. Yeah, plus static is not necessary because when you're boxing something, it defaults to static lifetime, I'm pretty sure. T try hash self hasher. T is try hash. Implementation of try hash for a box. Okay, so this is now impossible to do based on this implementation, right? Because if a boxed t, if t implements hash, oh, of course, classic. I'm starting to like think that my original way of doing things, where I would just like panic and I use a normal hash, is the easier way to do this thing. What do I do here? So I remove this implementation and just write all the implementations manually, right? I can also have my derive macro to like, I can annotate some fields. For some fields I will use the try hash, and for some fields I will use the std hash. I guess that could work, right? So now I actually need to do that, right? Like, here's what I'm saying. These fields would be like no try, you know? No except. Is that what you say? No try. Try hash. No try. Something like this. No fail. Try hash std also is another option. Try hash std hash. No fail. Sure. Do I annotate every field then like that? Is there other alternative? Can I do it like this, keeping the blanket implementation? I don't think I can, right? I cannot have the box implementation then, at least for sure. Yeah. Okay, well then let's do this then. Let's do this then. Macro rules. Implement std hash. Implement std hash for like subtypes. We cannot do negative trade bounds. I don't think so. Maybe it's like in nightly somewhere. Rust a negative trade bound. I'm pretty sure. I'm not even sure that this thing is in nightly though. I need negative trade bound. Actually, trade bounds is something we do need this feature in the language along with specialization. Build a package on the bottom of the end dependency chain, such as executable, we are most of the time protected by the orphan rule. When building a package in general, people do tend to use specific versions that they need. Breaking changes are still possible but avoidable. Maybe this feature can be split into two parts, like the specialization is currently. First one, given the ability to only apply negative bounds when both the negative bound and the type that is implemented are defined in the same crate as implementation. Yeah, or the second can be perma unstable, like some other features. Yeah. I think I just implement this for some like built-in types. That's how I do it. Types, type. Something like this. And then we do implement try hash for type. And I say that type error is boxed in s3 error plus send plus sync function try hash. It's like almost like specialization for concrete types, right? No, it's the other way. So I just do std hash self hasher, and then okay, right? And then we do implement std hash, and I will specify the types here, right? Like i32, i64, and a bunch of things here actually. Like here's the I don't know. It's so annoying. We can do a new type is another thing, right? We can do a new type. We'd also annotate the whole type to use hash for all fields or make it default. Yeah, maybe make the hash the default and only try specific fields. Yeah. True. But I still need an implementation of try hash for a box thing. And I literally cannot have that thing. Or wait, I guess, yeah, no, I can do it, but I need to not have the blanket implementation like this, right? Yeah. All right, let's try that too. I'm going, so then I need for my fields to find the thing that is try hash, I guess. So every field is going to have like, do I need to try it? Do try is just a boolean basically, right? To do try would be field attributes, iterate any attribute dot is a attribute dot meta docs in attribute meta returns the path that begins this structured meta item, like test and test, derive and derive, and path in path is equal to this attribute dot path is equal to try hash. It also means that I need to have over here attributes try hash, right? Cannot compare path with stir. Is ident try hash. Okay. Yeah, let me do this. Function hash fields then fields is impl iterator, item is field. This will return me a token stream for proc macro 2. This is going to be this thing. Yes. Well, I mean, it's going to be quote. And then I'm going to repeat everything, and I'm going to say hash fields. Just repeat all the hash fields, where hash fields is fields dot into iterator map hash field. How about that? And then we have function hash field, which is field into token stream. This is going to be basically, I'm going to match if field do try, then I do one thing, otherwise I do another thing, right? So in this case, I will do try trait. So try trait, now I cannot refer to it. Try hash colon try hash colon try hash ident Asher, question mark, quote. Ident is field new name. If it's not, then I do the normal thing, which is std hash ident hasher without the question mark, right? So over here, I will need to do a pattern match then even for a struct. So I will say self. I will say self field names, field new names, which needs to be repeated. Be self. And then over here, I say hash fields, where hash fields is hash fields, the fields of data fields, right? Field new names, field name. And over here, I also do hash fields. Hash fields is hash fields, fields of variant fields. Nice code. I mean, it works. It's still really short. It's just 100 lines of code, right? Cargo test. Try hash. So now try hash is not implemented for i32, right? So try hash is not implemented for i32, but I also did not use the try hash on the field, did I? Oh, I did do it. There we go. Okay, the trait hash is not implemented for foo-struct. So like over here, since foo-struct over here is the one that actually needs to be tried, right? This is the one that can fail. This one is going to have the attribute of try hash. Right? Like this. There you go. And then it works again. So those fields that need to be tried, I attentate with try hash, right? Hash field, hash, try. Yeah. All right, let's try that. I think this is me derailing. I am not making progress on the language by doing this. But sure. Variant. This needs to be try hash. Right? This tuple needs to be try hash. And to implement try hash for tuple, it is what it means also. Right? Function type. Try hash. I mean, actually, like a lot of the things here are try hash. This is normal hash. Function type.
23 months worth of subscriptions.
Nice. That subscriptions wasted well, I guess. Alright, trade bound vec try hash is not satisfied. Okay, so now we need to implement this for vecs, for boxes, for all kind of things. For vec t try hash. Let's see here.
19 months worth of subscriptions.
Oh, I thought the first wasted 23 months was from Nerdcell. I didn't see it was Davey. Hello, Davey. How are you doing? Try hash. It's nice, like wasting things is what we do on this channel. We are wasting time, we're wasting subscriptions, we're wasting everything. Right? So here I do for value, for element in self, element dot try hash, hasher, question mark, okay, right? Consider introducing a where clause, the size for t. Wait a second, the size for values of type t cannot be known at compile time. Why does it need to be though? Oh, because, okay, so to store things in a vec, we need them to be sized, right? Okay, sure. I guess that's true. Wasting hairline? Huh? I don't know what you mean. Hash is not implemented for type. Trade bound tuple type try hash is not satisfied. Okay. Tuple. Do I have tuples here? I do have tuples here. Try hash workspace. True. I'll just implement this here directly. Mm, mm, mm. I think I do write the manual implementation here. T, which is try hash. Try hash for tuple t. Type error. T error. Try hash. Services activation enable true. There's only the socket activation for the virtualization in kast. I don't think that's yeah, I don't know. I don't know that's what I want to do, right? We wanted to do the Linux activation, but that option is not there actually. Oh, Betcov. um try hash. So I go for unnamed and self unnamed try hash hasher question mark for name value in self named for name self named order. Name dot hash 3 hash name hasher that value is self named name value try hash hasher question mark. I think I can do big emotes fast enough to level it up. You mean the hype train? Oh, train. Yeah, there was a time when I was actually writing code this fast, as in on this emote. But yeah, today we are doing it a little slower than you know normally. It's fine, you know. There are slow days, there are quick days. Type hash is not satisfied. Value. Okay, so value should also implement the try hash actually, not the hash. Right, so this should be try hash. This should be try hash. This should be try hash. Variant value try hash. Try hash. Try hash. Do, 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 do. Now I need an option to be hashed. Let's go here. Import t try hash for option t. Right? Type error is t error function try hash. So then I just do std hash std mem discriminant self. Sure. And I say if let some value self, then I value dot try hash. Sure. And I do okay. Right? Okay, what else is to be done? Okay, so this is a hash map. Okay, wait a second. I didn't think this through. Even if I have a even if I have a try hash trait, I can not use it for a hash map, right? A try hash map. Okay. Let's see here. Struct key. Struct key. Is going to be a value and target value, right? So I'm going to derive try hash here, try hash and try hash, but then I'm going to implement std hash for this one. Okay. Hash. Ah, shit. Where's my completion? Because for yeah. Function hash. Self try hash. Date. Unwrap. What did I call it? Hasher if it is called state for the std? I don't know. But yeah, I'm just going to have the key and implement the try hash here. Partial ek and ek. Sure. Oh. So this is going to be the key. So this means, okay, so now implement cast can fail. I will say IRE result here, right? This will be IRE result, or. So the reason this is going to fail is, so key construction, function new value, and target value. This thing can fail. Right? So let key is self value target. I was just going to check if key try hash. How do I make a new hasher? Where is my auto completion? STD. Where's my auto completion? Hasher. I need to create some default hasher. New. Try hash into mute std hash default hasher new. Right? If this is okay, I just do question mark here and then I ignore the result, I think. And then I do OK key. App error E IRE E. So over here, I'll say that over here key new question mark and then insert and then OK. Right, and then over here, this is also going to be key new. I have a question mark here. Yeah, let's just do this in the very beginning. Key is that. I will return OK of that. Return also OK. Get does not value hash. Yeah, okay, because this is a hash map from key to value now. Right? Okay. Did you agree to the GPL license when installing Linux? Was I asked? What does the Linux's license say though? I can use it without purchasing the license key, right? I'm pretty sure I can. So I'm not actually like doing anything wrong with without if I am not activating my Linux, right? Pretty sure it's fine. Just like with Windows. Is it fine with Windows? Like the evaluation period can just last forever, right? I think. Match arms have incompatible things. Self cache, casts, lock, cast. Value target. I need to do... Okay, so this thing can fail, so do question mark. Okay, sure. Trade bound, function type, try hash is not... okay, this should implement try hash, try hash, try hash. I'm almost there. This should be try hash. Function type, try hash, typed function should implement try hash. What about the function itself? This can be normal hash. So this should be a try hash. This should be try hash. All right. I hate what I just wrote today. Maybe I should just commit this and then revert the commit immediately because I hate it so much. If you do not activate Linux, eventually it will downgrade to macOS. And your browser will be replaced with Opera GX. Oof. Result that must be used. Over here. Implecast question mark. Try hash. This must be used. This should be question mark. Yeah. There you go. Okay, now the question is, why did I do that again? What did we start with? Let's see. So what all I wanted is to have a tuple type, like std_int32 and std_string, right? This needs to be converted into type, which I cannot do, which I could not do, because of something, std type. There you go. So now we have, instead of a panic, we have like the actual error, but it does not give me all the stack trace while validating kast expression. So like this expression failed because some type is not inferred. Should I say that if okay, hold on, if I want to have a stack trace of this, then I should say, like, if a hash is failing, then what is the type that it's a part of that failed to hash, right? Or something. Yeah, I can do the context here. I can do the context here. Can I say dot wrap error? I cannot. Maybe I need to wrap the error here. Yeah. Wrap error with. What did that do? I recontext. This is already loaded though, is it not? Wrap error with. I value, which means that I need to clone the value here because I want to. Maybe I want to clone this thing. E. Cast key. Value is this, and target is this. Value target. And now let's try. This, like, I'm just realizing that this is not going to give me any useful output anyway. Can I do std_int32 as std type? Like that already works because it already is a type, right? Std string. Wait, hold on, this works now. Wait a second. What did I just do? And didn't I just do the same thing? std int32 std string std type as std type. The target is type not inferred. There you go. Because I'm trying to cast this into the not inferred type, because std type, hold on, std type is type not inferred. Wait, what? How did that happen? I think some of the previous errors are actually like modifying the state of the interpreter here. Maybe std type is type, right? But whenever I do, but if I do std int32 std type, this is still correct. std int32 comma std type. Now it's not inferred. That feels like a bug. Wait, what? How does that even happen? I don't know. I know why this happens. I'm not sure. But specify the FS sound that expresses the state space of your interpreter. So I'm using the thing. So for the inference, let's see here. I will still commit. I and I will say try hash. That's done. But the problem is that I am actually using global mutable state, which is like that. And when I'm returning errors, it doesn't mean that the state is not modified. Specifically in the inference algorithm here, when I'm making sure that two inference variables are the same, I am still modifying these variables to be the same. So what I'm doing here is I'm modifying the two variables to be the same, and then I'm doing the checks, kind of something. Doesn't matter if it's global or local. What does not matter? Have I specified the finite state machine? No, I have not specified any finite state machine. Why would you do that? Um, do I have a separate state machine? I have no state machines. Well, I mean, I don't know. You can call everything a state machine. I don't know what you mean by state machine, I guess. The problem is that I'm modifying the state even if it is going to end up being an error. So I'm not saving the old state, I guess, is the problem here. You do it because it helps you catch out wrong and missing transitions between interpreter states. What is a transition of the interpreter state? And show me an example. All right, show me an example because I have no idea what you're talking about. The problem is that when I'm changing the state, it doesn't matter if it's a state machine or something else. When I'm changing the state, I'm not saving the old state. So I cannot roll back. You can post a link, yeah. I think I don't care though. It's just that I can't really like follow. Maybe let me see here. It's a little annoying though. But but I can implement the snapshotting and rolling back here for the inference, I guess. The command line parser, split on separator, but not within quotes. This has the state machine, sure. I know what a state machine is. That's not what I'm doing though. I'm not splitting the on a separator, the thing. I'm not parsing a command line. Having states like this doesn't make sense for me. I think I can ignore this for now. I think I can ignore this for now, so we just need to make sure that, like, okay, it just doesn't work after the first error. I mean, it would be nice if I could make it work. Okay, sure. Let me try to do that, because it's going to be annoying in the future then. So I need to make sure that I save the state. Right now, I'm using my inference variables. Those are literally just like arc mutex shit, right? But instead of this, instead of an arc mutex, I need to, like, what? How do I make sure that I can roll back these things? So this should go into some, like, inference state in general, which would, like, we would store over here the index into this thing instead. Right? Variables is what? I can just do a vec. Right? We could do like an arena. It doesn't matter, I guess. I'm going to do maybe. All right, let's do a vec of variable states. T. We could also we don't have generic statics in Rust, right? Rust generic static. Is there a way to create a generic static? I guess we could do it with a map from a type into the storage for it. Maybe. But then since this is okay, so inference state for T, inference, let's call this concrete state, and then inference state. Let's call it mod global state. Down. Concrete state. 30 seconds until the fried effect of Factorio. All right. Sure, we can take a look. Hello, Veldak. So this would be an any map. So a map from a type ID into a boxed in any, I guess. Concrete is a hash map from type ID into a boxed in any. I think you copied the wrong link, Beldak. Fine, I'll open the link for you. There it is. The cargo pod deep dive. There audio? There is. Down, down, down. All right, they just talk about how they implemented the lore behind the cargo pad in the new Space Age DLC of Factorio. If anyone is interested, we're playing the Factorio on my other channel called Scooby Boy over there. But let's continue with programming here. So I'm trying to do this, and I'm going to have a static state, which is going to be once lock of state is once lock new, something like that. std any cannot be shared. Can I do boxed in any send sync? That's what I should do. Okay, let's see what. So what do I need to do here? I need to have a public function a snapshot, right, which is going to give me a snapshot Right, so I'm going to have a struct snapshot with something inside, and then I'm going to have a public function revert to a snapshot. Maybe, I don't know. Something like this is what I need to do. So this means that the states of all variables needs to be like saved. I mean, I can just like the snapshot can literally be like the current entire state then, right? I can like literally save it. So snapshot would have the state like just stored inside, I think. Nerdsel deleted Nerdsel's message. Huh? What happened there? Snapshot. So we just do state. All right, let's see. Get state dot. How do I do? How do I use the once lock? State dot get or net. So I'm just going to have a function state, which is going to give me a static state, right? This should be state dot get or init, and initialize using state default, which means that I'm going to just derive default here, I think. It's not span shot, it should be snapshot. Those are different things. Snapshot, so I say state dot clone. So this should be clonable then. Wait, didn't any be cloned? Didn't any be cloned? No, it cannot. I cannot have a din clone at all, right? Can I? I'm pretty sure that din clone does not work. Rate. Rate concrete state trait. I do boxed in. Concrete state trait. This requires send and sync. I'm going to implement for any type T concrete state trait for concrete state T. This should have a function clone. There's a din clone any in any map. Maybe I should just use any map here actually, you know? I like, because I'm trying to implement any map here by hand, right? I guess I just do cargo add any map. Any map 3, it's a different thing? Sure. Okay, just any map 3. Okay, so then concrete would be not a hash map. This should be any map 3. Map application containing 0 or 1 values for any given type and allowing convenient types of access to those values. Do I want any map or do I want map? What's the difference between map? If you want the entire map to be clonable, use clone any instead of any. Any map is a type synonym, which is map or din any. But I want to have map din clone any, right? So I want to have a map, and they say that I should use clone any, right? So din any map 3 clone any, right? Like this. That's literally what I was writing by hand here. Okay. But can I say send and sync too? Does this thing implement send and sync? Hopefully. So then snapshot where state is state clone, like this. This also, since this is one slug, this should have be behind a mutex, right? Just say default default, which means over here this is not this is static mutex, right? So state log wrap and then clone is what I want. So when in order to revert, I would need state log unwrap, and then star is equal to snapshot state, right? That's how I revert the state to be back. Okay. Sure. Okay, derive clone. If I derive clone, then okay, t must be clonable. Sure, which means that var state must also be clonable. Which means that data t must also be clonable. Which means that check must also be clonable. Can I have din fn, which is also clonable? A clonable fn? Okay, I just use an arc here, I guess, instead of box, and that will be clonable. It's fine. Arc new check. Okay. So now instead of doing the arc mutex here, since this should be instead this instead of being an arc mutex, it should be like an index into some concrete state here, right? So state would be I mean, is it just the index here? Let's have global state index. I guess I will call it ID because maybe I will move away from the vex. Type ID is use size for now though. Well, I need it to be T, right? Abstract. ID type T. Okay, let's do this. Sure. Phantom data T. Index use size. Right? This should work like as an arc mutex, basically, is what I'm saying. Import phantom data. Does this need to be? It does need it. This means that ID must be clonable. Get root. So instead of using arc mutex here, this should be like global state ID. And I guess I'm just giving it the ID back, right? So So instead of a lock unwrapping, I need to have something like global state. Get. To implement t idt function get itself. This should return something. Do I do something like state dot lock dot unwrap dot concrete? So I need to get from the concrete. I need to get from the concrete the concrete state for type T. Can I get entry for concrete state T or default? T cannot be sent between the threads safely. Okay, T is send plus sync. Hello. Hello, Infinite Coder. How are you doing? I am doing something really cursed today. I don't know. So I'm going to get at the index here. Dot the concrete state has the variables, so I will get the variables here at the index self index expect variable not exist question mark. So this now returns an inference var state. But I want to, so hold on, can I have a lock guard, a mutex guard? Do have a mutex guard in the std? I have map. No, we cannot map the guard. The mutex guard is like guarding the original thing only, right? Okay, so this is going to give me the var state then of type T, which means that I need to clone it here, right? So what I need to do is I need to do a get and I need to do a set then too. Set var state T. This is so cursed. Concrete state default is not satisfied. Default. What is the aim of the language? To be a killer of every other language. Of course. What else would be the goal? Why else would I create a language? Irendel. Hi. The goal of the language is to fix the problems that I have with other languages. But this is a big project, a very big scope, and I'm not sure that I can do it. So, like, mostly I'm doing it for fun. But maybe, potentially, I can actually do it. Who knows? Conquer the world, yeah. T default is not satisfied. So when I'm deriving something, when I'm deriving default, the problem here is that deriving defaults adds the T colon default, like a requirement for the default, so I need to do it manually actually. Impl default for concrete state t, like this. Yep. Did it just fail to... Do I have the syntax error somewhere? I do have syntax error. Yeah, this over here. Value. T may not live long enough. T must be static. Alright, and now I say that state lock unwrap can create entry or default values. At the index is equal. Let's just do insert self index value. And over here, I will get self-index. Instead of using a vec, I will use the I'll use a hash map from like ID view size. Sure. So the ID, in order to get it, I would need to total states, root or not root? Well, I mean, when I create it, right, I need to have public function new with original value. I think I can make this a very generic thing. New, this should return self. So I should just have the ID. Right? So for ID, I would just have static next ID is comic view size. Zero. Next ID. That ID is next ID dot fetch add one. Ordering something something. So I just return self. I index. This is index. Next index. I don't know. Index ID doesn't matter. Phantom data. Phantom data. But I also should say that let result be this. We'll also say result set value and return the result. Pow, pow, da-da-dum. Var trait, var state. T clone is not satisfied. Wait, what? Okay, get. The method get exists, but its trait were not satisfied. T sync. T send. So this now must be sync plus send. Plus static, I guess. Train bounds were not satisfied. Which bounds? Right, it should be clonable, I know. And then it cannot be the reference. There we go. Mm, mm, mm. Self get root closer to root. So over here I was mutating it, but now I'm not getting a mutable reference actually, and in order to mutate I need to save it again is the problem. To mute this value is this get match this value something 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 closer to root. So instead of using arc mutexes, I'm using global state ID of self. Global state ID T. Yeah, I think this should be like more generic. So like this should be just T here, I think, without being the var state, so that this could be reused in other places. So this should not be var state. I'm just storing the values of type T, I think. Right? Is same as others. So like get root gives me ID. So instead of so since this is not an arc, but like the this thing. Just say let's just say global state pointer equal which is just checking that the IDs are the same, I guess. trx a idt b idt a index is equal to b index. Consider removing the borrow. Get root gives me the ID. Pointer equals ID. Because the reference must be here. I'm stupid. Get root. This should be reference to ID. Self state must be ID. Okay, now ID not of this, but ID of the or state T. So T clone send sync static. I should probably like have a thing that can be like a variable, you know, trait variable data and clone send sync static. Implement T clone send sync static or data for T. So this should all just be for data, right? So so instead of locking and wrapping, I can I guess say dot modify state this. So yeah, I can have another thing that is going to actually modify it. So get set and modify self f impl fn once mutable t r r all right, so let mute value is I guess they just do f. That is easy without actually cloning it. I guess cloning only is necessary for the get method actually, but yeah, whatever. Parse get mut add self index expect, and then I do f of that. Okay. So this should be global state ID new, right? T cannot be okay. See, T should be inferable plus var state. Maybe like inferable is what it should be actually. Hold on, I already have this trait. As just inferable. That's what I store in my variables, right? Clone send sync static. Yeah, root. Dot get as a root value clone. A root lock. Root is okay. So this, since this is going to mutate this, I need to like modify this here, right? Okay, I'm going to get root var. So in the end, if everything succeeded, then I'm going to say root var dot set root because I have mutated it. Root data. Instead of arc pointer equality, we do global state root locked. I just do get here. Over here I also do get. So I just change these. And then I need to say that root state dot set root state root locked. Other root state dot set other root locked. We should change the names now. No way, it compiles. It compiles. So now I have snapshot and I have revert. Now the question is, does snapshotting and reverting work? So let's first check that I didn't break anything. If I go into the REPL, if it actually going to still work, maybe it's already broken. std int32 is an int32, all right. So if I say std int32 comma, that's a tuple with only single element. If I say that this is a type and this is going to break, and if I say this again, and std type is actually, so like right now std type is actually like not done like that. But the reason is different. The reason is not, it's not breaking. So I actually fixed the thing, but I fixed the thing like with a different solution, kind of. The problem is still there, technically. I just like, how would I show it? It's just I don't modify the state now in place. I modify the state, and then after everything succeeds, only then I am setting the new state to be the new value, right? After nothing failed. Which means that if a failure has happened, then I'm not modifying the state. But if a failure like has happened like in something like recursively, then it should, I don't know, something could still happen here, I think. I want to try to use this snapshot mechanism somehow still. How would I use it? What could I try? Should I like have an actual thing that reverts the thing? Like, because I can save the snapshot and revert it using the language itself, then I can give the language the ability to save its own like state. I don't know if that's a good idea. Probably not. Tyson or Paul? Paul, I guess. I'm not really following that shit though. I'm not really interested. I understand what you're talking about, but I don't know. I mean, I did saw one image today when where Tyson slapped Paul, I guess. That's the only thing. The last time I heard about anything or like related to that was like a month ago maybe. Yeah, I don't know. I'm not interested in that. Mad Basha, hello, hello. We're doing programming here, you see? It's like kind of a little bit off topic here. Just a little bit. Chair or table? Do 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 do. I don't know. I mean, I know what a table is. Like a hash table, for example. Is there such a thing as a hash chair? I don't know. I mean, a table is where multiple a table is something with multiple seats, right? So it means that a chair is something with just one seat, right? So I think a box in Rust could be considered a chair then, right? I just named incorrectly. Why is it a box? Why is it even called a box? Anyone knows that? It should be called chair because there is one thing that's sitting on it, right? All right, we can fix all those issues with our own programming language here, including the naming issues. Can I say something? Hold on. I think I can do it. If I do something like this, look at this. Const please infer x is underscore, right? So underscore is the not inferred thing. X is not inferred, right? But if I say something like if I say something like hello, which is x, which means that x is going to be assigned to a string, and I say like +5, right? Now this is not going to compile, but even although this did not compile, the assigning of x to string still happened, right? So we know that x is string. So if I think I want to do in the interpreter, in the REPL, if an error occurred, then I need to like revert the data, right? I think that makes sense. So in main, in my REPL here, I can do run REPL. Run REPL. So if this over here returns an error, I'm going to match this. If it was okay value, then I have a value. If it is an error, then I'm going to rethrow it. Return error E, right? But before returning this, I'm going to revert my snapshot. Right, so I'm going to say inference. I say kast. Inference. Vert. Snapshot. I'll make it public for now. It's fine. So now inference global state revert, right? I make this shit public. And so snapshot is I'm going to take it before evaluating the source. So snapshot is cast inference global state snapshot. All right. Snapshot is private type. This has to be public. Okay, so once again, we just say let x be underscore, right? X is not inferred. And if I say hello is of type x plus 5, this is not going to compile. If I look at x, it's still not inferred because I have reverted my state now, right? Okay. All right, I did something really cursed. I think, I don't know, maybe not. Maybe that's okay. Snapshotting inference state. Sure. Okay. Can we get to like the actual features that I wanted to do today? What did I want to do? I wanted to make the tuple types. String. This. std type. Right? That's what I was doing, and then std type was after something like this. Use std star int 32 this type. So type was like becoming a not inferred thing. Now it's fixed. Okay, good. So we want this to work basically, right? Because there is a difference between, once again, a tuple of types and a type, which is a tuple. Right? I can convert this into type by doing the as operation, by doing the casting. But by default, when I'm evaluating a tuple, it's a value tuple, not a type tuple. So how do I solve this? I think the way I solve this is similar to numbers. So I'm not sure though, but maybe that's how I do it. Like like mm, mm, mhm. Like, you know, when I say 69, it doesn't know what is the number type, right? I do not have any defaults. In order for me to evaluate any number, I need to say that it is an integer, or I need to say that it's a floating point number, right? Number literals cannot be treated as float. I can fix that. Number literals can be treated as this. Okay, I can say that float 64 can be correct. Literal 1 std float 64. Okay, nice. 1.5, right? But 1.5 can be treated as float, but not as an int, right? Because invalid digit. Literal number. Literal as float 64. So the way it's solved in like something like Rust is when you say something like this, and if it's not inferred, then it's defaulting to an int32. This feature is still going to be useful if I want to use my language as a calculator. Like I'm using Python normally to calculate 2 plus 2, right? I want to be able to do this too, right? So I want to, like, if I don't specify the types, I want it to be defaulting to something. But I think that default should not exist by default, but I should opt in to having the default. We'll see. Maybe I will have like the default of int32 like in Rust, but I think I don't want any default at all. Non-default default. Well, I mean, so like I think it would work with the context system that I don't have implemented yet, but like contexts, since my compiler is an interpreter, we can have contexts at compile time too, right? So with a context, I would be able to write something like with the default number be int 32, right? And then I like evaluate the other things, and whenever I see a number, it's now by default going to be an int 32. Something like that, you know? Compile time context, yeah. Compile time contexts are going to be used for other things, like the target, compilation target is going to be another one example like that. Yeah. I don't have contexts yet though, but I can implement the default mechanism anyway. The only question that I have is, so like when something is not inferred, when do I actually assign it to the thing? When I want to evaluate it? I guess? Maybe? So when I, so here we have our inference algorithm, right? And my inference algorithm should now have, when I have a variable, right? Variable state, here's my data that I store. We have a value which is optional, right? So this is some value if it has been inferred. If it has not been inferred, then it's none, right? But we can also have like the default value, right? Which I am going to assign to the value if the value is still none, but at some point I want to just use a default if it's not figured out yet. Maybe that's how it should work. Okay, Doru, hello. Does that make sense? Like, when does Rust assign these types? Is another, like... I mean, for Rust, it doesn't, like, matter the time when the not inferred types become the defaults. Like, the reason the timing matters is because when I assign this to anything, this can progress the type inference in other parts of the program, you know? Yeah. Something like that. Okay, let's have the default value. Let's just see if it's just going to work. So value and default value by default are both none, right? I want to like have the new, but having the default, new with default being like t, right? So default value in this case is going to be, default is t. So over here, default is some default. Some arc new default. Sure. I don't know why I'm using arc there, but okay. This expression creates a reference. Field default value is never read. So I think on my inference variables, I should have a thing which is going to be a function assign default. If not inferred, is there a better name for it? Is there a shorter name for this? By the way, cargo test. Did I break anything else? Because I did not run my tests, just in case. Okay, now the tests still work. Okay, good. Assign default is not inferred, so I'm going to do this, and I'm going to modify it, I guess. Root has root value. I guess I can just say like get or default, right? The default is not always specified, so this will still be same as get option argt, right? But what I'm saying is that if root value is none, right? I'm going to clone, so I'm going to, let's see, match. Okay, let's see, if root let is root as root value clone, if root value is none, then root value is root default value, right? So I just literally replace the value with the default value. I will need to run checks here again, which means that since this is can fail now potentially, this should return result. And I just clone the value, turn OK. Right? So let's try this with integers. I think it's the easiest to have a default on the numbers, right? So I will have, so I just have this, number literal type could not be inferred. Could not be inferred over here, right? So before doing this, I will just say that if data type inferred is error, which means that it's not inferred, right? Wait, hold on. What's inferred? Inferred is get, map, okay, self, 0. What? Maybe I should have over here just a method similar to inferred. I should have inferred or default, since this thing should have a default there, right? So this should be very similar, but it should be get or default. And this can fail, so I will do a question mark. Result. Sure, and similarly to that. New not inferred with default. Inferred type. New with default. Sure. So I don't get insert, I get insert or inferred or default, question mark. Right? Okay, so this is still not going to work because I'm not setting the default anywhere. 1, 2, 3 still could not be inferred. Right? But where it should be done is where I'm initializing the thing over here. So by default, in it here, number, right? So the type of a number by default is not inferred at all. New not inferred with default. With default. All right, let's just have the default here being inferred type int32, right? It can also like depend on whether the number literal has a dot inside or not, right? That would be literally the same as Rust. If there is no, so it's a floating point number that it would default to a float. What's the default, by the way, in Rust? I don't even know what the default is. Function foo. Function main. Let x be 0.0. The println. std any type type ID of value, I guess, right? Let's see. Function show type x t type ID of t show type x. Wait, how do I get the name? Wait, how do I get the name? Oh, type name. Oh, they have type name of value. There we go. That's all I needed to do. std any type name of value x. And find a function type name of val. Mismatch types expected a reference, of course. So it's f64. Okay. And the normal integer is default to int32. Yeah, okay. So yeah, now I'm doing it by default to int32. How about I do something like match self kast compiler default. I don't have compiler, right? Default number. I guess I don't match it. I'm just going to set it now here. Compiler. Default number type. Invert type. To do use compile time context. Why is this to do not highlighted, huh? Whatever. It's because in normal comments it's highlighted, but in doc comment it does not. Whatever. Default number type is int32. Right. I actually think that if I want to use this for calculator, I would actually, in my interpreter, have like, I don't know, it should be like either a floating point or, I don't know, a big integer, similar to JavaScript. Wait, hold on, does JavaScript have big things? Maybe like Python, a floating point or a big integer, right? I think I would do that, or just math. 1, 2, 3. Okay, so there you go. If I don't specify that, it's an int32 now. If I specify this to be an float64, this would change the type. Right? Okay, I have the defaults. Default values, default values, default inference values. Okay, we'll keep the int32 the default type. It also means, by the way, that like 123.5 is not going to compile. I guess the default could, yeah, like I said, like depend on the actual literal. And see if it has a dot inside, then it would be a floating point number. Yeah, it's fine for now. So now I want this thing to compile again, right? So like a unit. A unit is this. When I say unit colon type, std type. Wait, why does this compile again? Modblog, hello. Why does this compile again? I'm not sure. Does kast have casts? Yeah, kast have casts. So the problem that I want to fix is the one that is solvable by casts, but not without the casts. Specifically, I have two types of tuples. The first one, I mean, Rust also has that, but Rust does not treat two types as values, so Rust doesn't have that problem. We have a tuple of values, which is like hello and world, right? For example, this is a tuple of two values, which the type of this tuple is two strings, right? At two strings. But since I'm treating types as values, if I try to do this, string and string, this is also a tuple. But what is the type of this expression? The type is two types, right? But as you can see over here, the type of hello world is this. So the type of a type is supposed to be a type. But since I have shown, I did this here, the type of this thing is actually not a type, but is a tuple of two types, right? So in order to fix this, I can cast this to type level tuple explicitly. So this would be a type of two strings, right? But by default, when I'm evaluating this, it's a value of tuple of two types, where the first value is a type string and the second value is type string. You know, does that make any sense? Yeah. There are other casts similarly to Rust. We have traits implemented as casts. So we have in the standard library a thing that is called parse for parsing integers, right? So when I say parse 1, 2, 3, right? Which is supposed to be like an int 32, right? This is going to parse 1, 2, 3, right? The way it works in Rust by using traits, right? So you do it in Rust by doing a thing like int 32 as parse trait, right? I will just write it in cast directly here. Int 32 as parse dot parse 1, 2, 3. So this over here, this as operation is also a casting operation. So I can cast the value, which is the type of int 32, to the parse trait, which will give me the concrete parse function. So it's not like a special syntax. This is just like broken down into smaller features. The casting operation to cast a type into a trait, and a trait in this case is also nothing special. It's just like a generic type, a generic thing. And then the result of this is the concrete implementation of that trait, basically. If that makes any sense. Yeah, cast is a feature of cast. One of the most important ones. Basically, types are values. Yes, types are values. Everything is a value. I have other things as values. Here is another example. I can have so like, because I was working without like a lot of features, one of the first things that we would do is having AST as value. So if I say A plus B, this over here is a quote operator, like in Lisp. You can construct the AST value of a specific expression like this. I can also say that let like sum to be this, so like sum is a value of AST like this, and I can also use it in another, I can construct another AST using this, so I can say like, I don't know, x plus sum, this is unquoting, so this will replace this sum with the other AST, and I can like make new AST using existing AST this way. And then by having functions that operate on ASTs, we can have macros basically in this language, which are written as normal code. And yeah, if that makes any sense. I think that was easy though. But yeah, the entire thing that I wanted to fix, and I have been doing this for 3.5 hours, is just to make sure that the type of a unit is different from the value of unit, because this thing on the left and on the right hand side looks the same, but it's actually a different thing. So for that, I just did the default types for the inference. So whenever I see a tuple or an empty tuple, which is a unit, by default it's going to be a value. But if I'm going to say that it's a type, then it's going to be evaluated to a type instead. And I can expand the quoted AST back to code to evaluate. Yeah. So there are some like, yeah. Well, I mean, I don't have like the in language, like I don't have like the conversion to like eventually I plan to have intermediate representation as value very similarly to this, which will also allow you not to like which will allow you to take AST, compile it into the intermediate representation, then evaluate this intermediate representation to write a compiler inside the language itself, basically. While interpreting the language, I will be able to compile my code, the same code that I'm interpreting, to other targets, so I will be able to compile to multiple targets at once also, is the idea. But that's not done yet. We make the type and value be the same value? I cannot, because what's the type of it? What's the type of the type, and what's the type of a value? You know, the type of one of these is type, and the type of another one is itself, basically, right? If they are the same thing. But the type of a concrete value is a concrete thing, right? So for that reason, we have a type level tuples and we have a value level tuples. But I can convert a value into a type, right? So the way I was doing it before is over here. So get this value as type, right? So if a value itself is a type, then it is just that type. But if it is a unit value, then I am converting it to a unit type, right? But this is a hack, right? Similarly to tuples. Tuple, in order to treat a tuple as type, every single field of a tuple must be a type too, basically. Right? But this is like the runtime operation and not a compile time operation. But I convert a type back to value. I don't know why would I want that, but I guess sometimes, yeah. I mean, yeah, probably. Like we want to have type inspection. You know, like the entire reason for these types as values is for having compile time, comp time, I guess, is the word that is used these days, because of like Zig, where you can inspect the types, have compile time reflection, right? So you want to get the type, and if it's a tuple, you want to be able to iterate over its fields and shit like that, right? So you wouldn't just write normal code that would run at compile time. So you would need to convert, I guess, a type into a value. You mean I mean like types are already values, but you want to convert, I guess, a tuple type into a tuple value, I guess. Maybe I don't have that operation right now because I have not done such things yet, but they will be possible eventually. At least that's the plan. Okay, so I just want to get rid of these hacks, right? So the only thing that can be a type is a type. Right? I think, do I have anything uncommitted? No. So like I'm literally going to say that the only thing that can be converted into a type is the value, is if the value is already a type, right? This is going to break it, maybe even in the standard library. Yeah, over here. See, it says that unit is not a type because unit is a value in the standard library 14, stdlib 14, right? Because in order to construct the value, which is the type of a function, I need to evaluate this. So this should be evaluated to a type, right? Compiler function type over here. So when we have a function type, expression. Function type is an expression. So when I initialize it, I have commented this thing out, but the type of both argument and the result when I'm constructing the function type should be a type. Right? So this is going to have a different problem. It's going to say that binding t is not a type. Wait, I think I deleted binding for no reason. Value. I think from here I should still have a type. I'm just testing that the type of a binding is a type. Yeah. Okay, yeah, makes sense, makes sense. Bindings as values are also interesting, but I'm not going to comment on that too much. It's weird to me too. Maybe eventually I will figure out how to explain this. So yeah, there you go. I expected a tuple where left-hand side is something that's not inferred. Right-hand side is something not inferred. So like I expected a tuple got type, but tuple can be a type in that case. So it means that when I'm initializing a tuple over here, the type of the tuple expression is a tuple. That's what I'm saying right now, but that should be just the default type. Type new not inferred with default being this thing. Yo, Rinks, get a haircut? Yeah. How are you doing? Any game jams or something that's happening? Casting this into type is not implemented. This is not type. All right, I might need to delete my standard library for a second here. So that it compiles and I work in REPL. How do I even comment all the things? I don't know, I guess that works, just REPL. All right, std int32, okay. Nothing, std type. Okay, so this, wait, how does this work? I don't know. I think I did I did something with units actually already. Debated joining Betco, but then got lazy for the fun base alpha gem, right? It's there's still more time, right? I think it's not started yet. Use std star. Okay, int32 semicolon. So this is a tuple, but if I say that this is a type, wait, no, this doesn't work. Yeah, this doesn't work because I I never checked that my interpreter implementation actually matches the types that are inferred. right? Um, yeah, I can say something like x is underscore, and then I say int 32 is a type, and this is of type x. So even although I get as a result not a type, the type that was inferred was just type. Okay, so it's just like the interpreter that is wrong. Interpreter. Maybe I should have checks that when I'm interpreting code that the evaluated type is actually equal to the inferred type, right? That would be a good check to have. So when I have a tuple, you have stuff you gotta do this weekend. Makes sense. Betko asked me too. I think I'm not going to participate in any game jams in a while. Because I'm lazy, you know, too. You know, I have stuff to do like this thing that I'm working on right now. I have my own programming language. That's fun. You know, it's more fun than the last Ludum Dare was for me. I didn't enjoy the last Ludum Dare too much. Linksider, I'm working on Linksider off stream a little bit too. Hopefully we are going to get the demo before the end of the year, we'll see. Yeah, there's also plain Factorio, you know, that's also important. Okay, so I have this result, but sometimes I might want to have a thing here. So data here, this is the data, that is my inference data. I'm going to match data dot type dot inferred or default, I guess, if it is an error, and I will say the update released for Linksider. I don't know what update. Linksider, the only update is going to be when we release the game on Steam, I guess. Or I mean, we're going to probably release the demo first. Oh, for the Factorio, yeah, for the Factorio, the update is released. Yeah, the DLC, and it's huge. I've been playing it for more than 2 weeks already. So yeah, and I still am not done. Tuple type could not be inferred? Question mark. Can I have like comma? Have a cause? Yeah. Error. Maybe I just wrap the error here so that tuple type could not be inferred. Return error. That's how I do it. And if I was okay, inferred type. Then I say value type result dot kast self. interpreter. Kast. No. Kast. Function kast. Kast map. Kast map. That's in the compiler. So it's cache kast map dot kast. I guess the
Squiggly rings.
result to be in the value tuple anyway. Result to word type.
Picorly.
Type.
Hello.
Hello, big early. Wait, what if like if tuples would be like casted to other types too? I don't know. Let me not think about that yet. Hello? It's called casts. Hello, hello. Oh, it's cache compiler dot. Yeah. Type. Cast returns a result with a question mark. Wrap dot. There is no wrap error. There is going to be map error. Tuple IRE cannot be cast into type. Question mark. So I don't need this to be a value type anymore because that already is going to be the thing. Cast requires a value, so value type into tuple cannot be casted into type. Inferred or default question mark. Okay, and then we can no method wrap error. Error here is variable. Okay. I guess I just do IRE bail. Tuple type could not be inferred. Yeah, that's impossible. Okay, if it is an okay inferred type tuple, but I don't care about the exact details, then I just return the result. If it is okay something else, then I bail equal expression type inferred as type, which is supposed to not happen. Now let's see. Use std int 32 type. Okay, so now the this thing cannot be cast into type. So I think maybe the casting is not implemented here. Let's see. Yeah, because I did the expect type here, but that's, yeah. Okay. This is casting into type. This is the only, like, yeah, because it was hard coded in the expect type before, and now it's not. Right? Yeah. So if I want to cast into a type, this will only succeed if the value is already a type. Right? But I guess I'm going to... let's say return okay, match value. If it is anything else, then I will return this stuff. Okay, if it is a value unit, then I need to say that it should be okay, value type. I'm already returning type, right? So I don't need to map it here anymore. But if it's a unit, then I will say inferred type unit into, right? Type error. Here's the problem with question marks in Rust, because I have a result for two different things. So I will need to do it. I cannot map error anymore because of that, right? I will need to actually match this. And if it is okay value, then I will return value. If it is an error E, then I will return okay error E value. Expected result. So I will return okay then. Here, okay. Okay, so we have a unit and we have a tuple. If a value is a tuple, and I want to treat it as type, then this is something that I had before. In the here, right? This is literally the same thing. So I'm going to return inferred type tuple, tuple type. That what tuple type is tuple empty. Then I say for name and value in tuple type, add name, value. So this should be still casting, right? So self cast. I'm going to cast them recursively, right? On the value into the type, right? So the target is going to be just the same because I know that the target is the type. So target question mark dot app error value IRE value is not a type question mark That it? After casting, this must become a type. Maybe I should have a public function cast to type self value. This should just be this. Result value. Yeah, let's just have that. And now I just return. Like I do want to get value back though, so result fine, result value fine. It's the same thing. So I just return self cast to type value, right? Then I do this here. Okay. Mismatch types, tuple values. So this must be a tuple of types, right? So this thing, cast to type, actually should return result type, right? Because that's what I'm casting into, which means that this should be map a result map value type. Is that what I want to do? So I don't return value type, I just return the type directly. There we go. Nice. The question operator is incompatible. Cast to type this value. That's all I need to do then, right? Question mark. No, I still need to map error here. Go. Parameter is only used in recursion. Yeah. If the parameter is only used in recursion, is that... I think I'm going to allow this. Allow Clippy parameter recursion. Only used in recursion. I think it's fine. Can I have a thing like that? To be... Okay. Like I can syntactically I can attach this to the argument self, but this does not remove the warning. Okay. Fine, we do this. Just REPL. Use std int32 type. There we go. So like this is two different expressions now. This expression gives me a tuple where we have only one field which is type, and this one is giving me type directly, right? Okay. Now the question is the standard library going to compile again? Let's try line by line. Std print hello. Okay. These defaults also mean that I can have a default string type, and I can treat string literals as like different types easily, right? Yep. If I say dbg123, std dbg123, this is defaulting to int32. So this also works. Nice. Does that work? Looks like it does. What about 1? What about 2 plus 2? 4. Nice. So I can actually use it as a calculator now. Officially. Okay, this is not type. Okay. As type. Wait, what? Wait, what? Wait, hold on. Which doesn't compile? In the standard library, line 37. Over here, parse. I'm trying to implement parsing for integer. I can define it easily. Okay, yeah, this thing does not work because impl int32 as parse. Dot parse is not a type. So okay, I see it. I see it. So this thing must be a type now, right? This thing now must be a type. So I need to have the templates which are types versus templates that are values also, I think. Like this should be a type. Literally. Right? Do I just do this as a type? And then it works, I guess. Because parse is a generic type, so this was defaulting to be evaluated to something else, yeah. But I also can, since I am doing as parse, I think, since I'm doing this, I can make sure that when I'm doing the these things and I've seen a template, the template must evaluate to a type eventually, right? Yeah, I think so. Let me see this. Impl in compiler. Impl kast. So when I'm doing impl kast, value should be this. Yep. This already has been evaluated though. The thing on the right side. And everything on the right side is a value, so I guess it does not matter. Type insert the target. I mean, I don't even check the types here, right? Or do I? Wait, hold on. Cast result type. This is the thing, right? Cast result type. Yeah, there you go. So if my target is a template, then you need to call this. But what I need to do is this template dot compiled. This may be compiled function. This does not have types. The templates don't have types to it. Well, I mean, I'm calling it, so it is compiled. But instead of expecting type here, what does callFn do? I need to like make sure that it's compiled, right? Public async function ensure like await compiled, I guess. function f. This should give me the park compiled fn. Which means that I should advance the executor and then do this. So this should be self await compiled f question mark. And this potentially fail. I don't know. Let's say that it's going to fail. So I'm going to, instead of calling this immediately, coffee required dev. Oh no, Rust. What do you mean? What do you mean? Oh no, Rust. Rust is oh yes. It's not like Go. Go would be oh no. Rust is like the opposite. Java OG. Oh. I'm sorry. I'm sorry. It happens. Java happens. There was a time when I was writing Java too. What about C++? Well, actually, like if we compare Java and C++, what would I want to write more? That's a good question. I don't even know which one would I choose. I think I would choose Java. Yeah, I think I would. But like, there is also like this other like question, I guess. Kotlin, I have not a good experience with Kotlin, but the reason I had a bad experience with it because I was trying to integrate it into an existing Java project, and I think that if you have an existing Java project, it's just better to keep going in Java. But if you start a new project that is pure Kotlin, then maybe it would be better. I would assume. Yeah. Kotlin is better than Java. I mean, a lot of the things are better than Java. It's not really a difficult thing to be better than. Just try a better game engine in Java, right? NeoVim. This is NeoVim, yeah. Is there any popular game engines in Java actually? Is anyone doing game development in Java except for the Minecraft developers? This is literally the only game that's written in Java. Are the mobile games for Android being written in Java still? I don't think so, right? Mobile games are all like Unity probably. No? Hmm. Or what? Android is Kotlin. I mean, it's Java, basically. But like, it doesn't mean that every app is written in Java. For example, I can make my my game that I'm working on. I can show you here in the corner. This game that we have in the works. This game works on Android and it's written in Rust. It does not like you can compile C++ and other things and make it work on Android. Well, 9% Unity, yeah. Yeah. I don't play a lot of mobile games, but that's what I would assume. So no one actually is writing Java when, like, for game development, seriously, right? Okay, over here, instead of calling this function, I'm going to say kast await compiled, await question mark, template. I guess await compiled can just take a reference here. I don't need that to be taken by value. So if this is that, then I'm going to say that type. Oh, wait, what do I have as a result? They compiled dot type. Ah, where was my autocompletion? I guess one thing that is Java is better at is because the language is so simple. The language server is actually working good there, right? Right? I mean, I didn't work in Java for a long time, so. It meant me working on programming language, not on game. I mean, what's the difference though? I would use Rust for everything. What is a better language to do language development, you think? This project was originally made in OCaml, by the way. Do you think OCaml is a better way? Is a better language to write languages? There's a lot of people who think that. But I didn't like OCaml too much. Zig? No, Zig is trash. Alright, it's not trash. Like there's a lot of features in Zig that I like, but it just doesn't have enough features. It's too simple of a language. It's too limited. I need an expressive language because I'm writing complex software. To write complex software, you need expressivity, and the language must not be simple. So yeah, it's better than some alternatives for sure, but yeah, I would never write C or Lua. And Zig is not very far from C. And especially assembly. Like, why would you want to write assembly? How about you just write the zeros and ones directly into, like, just write the bytes directly into the executable, you know? You can do that, right? Did I try something? It's funny, play with it? What do you mean? I did try something. You mean like some of those languages that you mentioned? I did play around with Zig. I did play around with Asm. I did play around with Lua and with C. I hate all of those. I mean, Zig is the better choice out of those, I guess. But still. Then why Rust? Because Rust is the better language. That's why. The only other language that is in theory like better would be Haskell, but in practice Haskell sucks. So Rust is the only good language that is left. There you go. Okay, await compile. This gives me the compiled function. Compiled function, I need to have the argument in the body. Okay, so there, that's what we do. We do body, data, type, expect inferred to be a type, right? I think so. Result that must be used? Yeah, sure. Mark. Usually people handwrite ASM for performance reason. Yeah, but like I'm not considered like no, I don't know. Like the only reason you write assembly for performance reason is if your program is like I don't know 10 times long, 10 lines long. Because for any complex software which is like 100 millions lines of code, you would not be writing that in assembly. I don't believe that. Unless it's like something like very like limited and like like really like its own thing that is small. Last time you checked, Rust has slow compile times compared to C++. Well, it depends what kind of code base you have in C++ and in Rust. My experience with C++ was that it was longer to compile than my Rust code, even although my projects were smaller. But like there is a big difference between Rust and C++, where in C++ you never use dependencies in the form of the source code. Usually when you, even if you add some dependency, it's either a small like header only library, or it is a dynamically linked library, in which case you don't need to like compile the dependency yourself, right? So like it's not a fair comparison because Rust uses static linking and static compilation, like it compiles dependencies like from source. Yeah, it's a little different. I'm not sure which one is actually faster because like there is no like actual correct comparison, I think, for the same amount of code. Just saw the other day FFmpeg tweeting about handwriting ASM for better performance. Alright. I mean, maybe. But like, right. I mean, yeah. I can see it, but like that's not what you do as your first implementation anyway. I don't know. I personally don't care too much about performance, so I didn't look into those things, but if you really want to, you can write assembly in Rust too. Inline assembly is a feature here, like in C++. You can also do that. Well, Nam, good luck with your project in Rust. Have a nice day. All right, bye. It's fine to disagree. I'm not sure what you disagreed with though. iSense, hello, hello. I remember this article by what used to be a favorite streamer and author of JavaScript linter, QuickLint. Is coding in Rust as bad as in C++? C++ is notorious for its slow build times. My code is compiling. Strager? Yeah, I remember this guy. So he actually did do the tests, right? Reported a C++ project line by line to Rust, boasts of 17,000 lines of code. This is what people thought, right? What is the actual result, though? You can also change the linker, yeah, and stuff. Crane lift backend. What was the end? It was C++ still faster there? macOS, C++ usually builds faster than Rust. Linux, Rust sometimes builds faster than C++. C++ incremental builds scale better than Rust. Sure. Anyway, so one of the ideas of the language that I am making, and like technically, it's something that could be done in Rust, where you could have not only the compiler but also the interpreter of your code, so that the like the prototyping phase would be quick, because you would not need to wait for compilation, but you would instead be interpreting the code. So the language that I'm making is supposed to be both interpreted and compiled. I'm not sure how Haskell does it, because Haskell also has like REPL and shit. Haskell is both compiled and interpreted. Is that it? I don't know how the REPL works. There was a conclusion. Our compilation time is a problem with Rust. Yes. No, I agree with that. That is a problem. Are build times as bad with Rust as with C++? Yes. I mean, probably, yeah. Yeah, build times are a problem. I agree. But looking at my hypothesis, I was wrong with all counts. The Rust port had more lines than C++ version, not fewer. For full builds compared to Rust, C++ builds took about the same amount of time, or took less time, not longer. For incremental builds compared to C++, Rust builds were sometimes shorter, sometimes longer. Always longer. All right. I don't know if like if it tells anything, because like in like technically C++ is an expressive language too, similarly to Rust. It's just like I wouldn't be that confident in my code if I was writing C++. Uh, do we? Okay, hold on. I guess I fixed the issue, right? Which is I am inside the REPL already. int32 as parse dot parse 1 2 3 cannot parse not inferred type. Okay, so this is a problem. Letting call expression cannot parse not inferred type. Oh wait, hold on. int32 as parse was not inferred here. This is wrong, because this should be an int32. Is it that my casting is wrong? So this is correct, but std and 32 as std parse becomes not inferred. Why not? All right, let me first uncomment everything else. All right. So that all compiles. What if I do parse to 3 int 32? Cannot parse not infer type. So like it's the same reason, right? So the core reason for this error is that std int32 as parse is not inferred. So why not? Cast. So since I was casting, I just do this. It's about the impl cast, right? I think. stdlib, let's see. So if I say here that this is string into int32, then this works properly. And if I can even pass the parse 3 32, that works, right? Because I have specified it here, but I should not need to specify it. It's supposed to be inferred. The way it's inferred is that the implementation type is the same as the kast result type here. So since this is a template, yep. Yep. That type. I am calling it with the value. And the value is my value. Value is t non to so the value in this case would be how about I do this? Just tracing info impl value as target be impl. It's supposed to work. So I'm implementing type in 32 as this. Be that. Implementing in 32 as template. This native function parse. Native function parse. How about I show the type of the impl here, which would be impl type. So yeah, over here we say that like it probably is inferred that it's a function from string into something, but this something is not inferred. Why not? Because kast result type. So like this thing is wrong. How about I show what the value is here? Law tracing info value. Like it's supposed to be a type in 32 there all the time, right? Or type in 32, right? So that result to be this result tracing info is equal to result. Mm -hmm. Mm -hmm. Type in 32 as this. Test result type 4. Type in 32 is string into int 32. Hold on. There you go. String into int 32. This is the correct type. String into int 32. But then over here it got reversed back to the not inferred for some reason. So kast result type. This is used in this place. Implementation type is that. Oh wait, hold on. I see it. So like, I think it's another problem where I set the type in the thing, but then when I evaluate it, the type is different. I think I should have this. So I have the result here, right? And then I finish the evaluation with the result, but I need to check that the type of the result is the same as the type that I was inferring it. Bad cop calling me out? What do you mean? Bad cop streaming?
List on here, do we? It was like 4 devs to varying degrees, and then a lot of Kuvi is here. Kuvi, you want to join our mega team for Fun Jam?
No.
18 hours. I know you said you don't want to do a jam, but what if we did a jam?
Squiggly rings.
All right. No. I'm not doing a game jam. Hold on. I have a programming language to make. I don't make games anymore. Yeah, I'm making like programming languages that like don't work. At least not yet. So I have the result type, and then I have the expression type, right? So I say that if these two are not the same, then I'm going to say tracing. All right, how about I do IRE fail expression expected to be of type this, but we got this of this, right? Expression data type result type. Nerdzel wants to do a gem. Next gem when kast is ready. Okay, so we are going to make it ready for the advent of code. We are going to make advent of code in kast, and then after that we can think about a game jam in kast. All right. Betkov wants to collaborate. How to? I never use this thing, Betkov. Hold on. Can you teach me? Let's accept. I know what's going to happen though. Get started. Hi. Hi.
Oh, hi.
Oh shit, it works. No way.
It works.
I didn't expect it to work on my Linux stuff.
I can do what? How do I do the camera?
I don't know.
Wait, send audio through browse. No, don't.
Turn camera on. Okay. I mean, hold on.
I can turn my camera on.
Click
Then you can put
allow.
it on your stream, I think.
Allow. Camera is used elsewhere. Okay, I have two cameras, but apparently they're both used in my OBS. I cannot show you myself. Yeah. Alright, anyway, how is Rust working for you?
Oh, I'm mostly doing JavaScript right now, you know? That's how
Alright, nice.
kind of how Rust goes.
Good for you.
Did you wanna do a game jam? I heard some people in chat saying you wanted to.
Yeah, I want to, but like so the plan is I make my own programming language and then I start doing game jams in my own programming language. Yeah.
And what about like tomorrow? Like
I'm not sure if I can get it done until tomorrow.
Well, what parts are missing? Maybe I can help.
I mean, maybe I can help with some small stuff, but I don't want to spend the entire
Okay,
day
wait.
like.
Let's think.
Yeah.
Let's think because the game jam is 9 days long. So we
Okay.
only really need like 2 days of the jam to make the game.
Uh-huh.
So that gives us 7 days to finish cast.
Oh, so you're saying that I should so I don't do it tomorrow. We do it in a week, right?
Oh my god.
We're going to like stall until the end of the deadline,
What's happening?
and then only start working on the game, right? Like usually. Audio exploded. I don't hear you.
Hold on. What is using this much? Okay, that's a lot of RAM. OBS is running away with RAM right now.
All right, I guess it's not my issue, right?
Hold on. I don't think it's the OBS memory leak. I think it's that fucking browser source for guest star.
All right, I might just keep working on my own stuff then. I'm almost done here with what I wanted to do. I just need to understand what the problem is. So yeah, there you go. I evaluated something, right? Expression expected to be of type string into int32, but I actually got a string into not inferred. Miguel, hello. Thanks for wasting points. String into not inferred. So how is this expression expect to be this type? But I got that. Wait, what? I don't understand. It's because, oh wait, hold on. I know why. I think I know why. Because when I have a tuple, so the fields of the tuples did not have any expected type. The guest star thing has memory leaks. Can you just rewrite Twitch in Rust or something and like not leak memory? Since you're rewriting all the things in Rust apparently now, and Tau, yeah, might as well rewrite Twitch too. I don't know if you're listening. You are? Okay.
I should just rewrite Twitch and Rust. That would be cool. It's a good idea.
Nice. Now you have to do something instead of game jamming, just like I do. Okay, see you later.
Okay.
Bye. Expression expected to be of type this, but we got that. So the reason for that is because I don't understand. I think I almost understand what's happening, but not exactly. So when I have in compiler this thing. When does this happen? So when I'm doing struct definition, when I'm doing impl kast, and a standard library line 37, right? Line 37. Okay. So it happens over here, right? When I'm trying to evaluate this, I'm trying specifically to evaluate this code, and this evaluates to the wrong thing. Because this over here is a tuple expression. Since this is a tuple expression, I think it's in the interpreter. I need to like do something. I don't know. Maybe when I'm initializing the yeah, maybe when I'm initializing the tuple expression. Dun, 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 dun. So I am initializing the tuple the expression, but the default type is this. Okay. I think I understand why. Because like because this is now a default type, it doesn't get unified. Like the fields not get unified. If that makes sense. That is this type. Add checks. I can convert inference variables into these things. Okay. So I'm going to make yeah, I'm going to make the type, but it's going to be not type, but it's going to be inference variable new with default being this type. The default is just a tuple. I'm just going to say, I mean, yeah, tuple. Wait, no, wait, what is wrong? I'm just tired here. Type into, I mean, I think I just need to add a check here. Type add check. Inferred. Okay. Learner lives. Hello, hello. Inferred is inferred types. Let's see. Right. Tracing info. Tuple inferred as inferred. I do that. See what's wrong. Tuple inferred as type, tuple inferred as type. And then it's just in an infinite loop. Is it in an infinite loop? Because it's trying to log it? No way. It is in an infinite loop because it's trying to log it. Is it like the infinite thing? No way. What actually happened? Why can I not show the type? Because type is referring to itself. Oh. Okay, how about tuple inferred? Wait, isn't this supposed to even like run instantly because I did that? But it never runs actually, which is weird. Inferred as type is inferred as type. When I do add check, it okay, it does not run the check immediately, sure. But root is state as root. Root checks push. Root run checks. Check failed when adding. Maybe I should make that function return result too then. Huh? I don't get it. Tracing info 1, 2, 3. Can I go here, please? One, two, three. Okay, so it's actually like showing this, which is not working. The implementation of display for this. Display for inferred type over here. I don't know. Well, because it's supposed to be a tuple. Hmm. Something is really wrong. What was here before? Hold on. Git log. Default inference values. Am I doing the default inference values for tuples right now? I am, right? So previously it was a tuple type like that. And now it is this thing. Mm, mm, mhm. Do I have a problem? All right, let's try debugging this. I have like a circular type or something here. I don't know what to do. I don't know what to do. So the problem was on just on initialization here, right? Because I was just during compilation, I didn't even get to evaluate anything, right? Tuple inferred, S type. So tuples that were inferred as type was like this thing, I guess. Or I guess these three things maybe. Can I show here tracing info question mark expression? I just show expression. Expression show short, is that the thing that I have? And find value expression. Self. Expression. Display. No. Show. Filing. This is ASD. Interpreter. Evaluating expression show short. Have it. No method show short for expression. Oh, okay, it's because it's not yet initialized. Yeah, makes sense, makes sense. Makes sense. Show short function. Show short. This should be not only for expression, but for expression where data has span, right? Data to the down. What do I do? As ref span. No field span on type data unknown field. Yeah. As ref. Yes. So I need to implement for expression data for span. Implement as ref span, which probably should not be as ref, but something else for expression data. Ref self span. Does that work? Oh wait, span as ref is also not working, right? Should it be std borrow? Borrow? That's not how you're supposed to use it though. I make my own trait, I guess. Borrow of partially moved value self. Yeah, I did move self here. Okay, can I clone expressions? Show short. This takes a reference. Fine. I'm trying to do the cast expression, and then it breaks. Expression cast. Because that requires me evaluating. Not evaluate twice. Oh wait, is it because I'm evaluating it twice? Maybe. Or maybe not. String into int. Like I know the type that I would have expected, but when I'm evaluating that, I don't know. Let's try interpreter again. So native type is here, right? How would I do this here? Tracing info native as actual type, native name actual type. So native parse, literally not inferred. It's not even a string into not inferred. It's literally completely not inferred. Why is that? Why is that? compiler impl kast. So it's because I'm evaluating the value, then I'm evaluating the target. I am compiling the implementation, tracing info. Impl is impl. Wait, am I even getting here? I'm not even getting here, right? Okay, how about I go here, tracing info, impl kast, ASD. I should do I have ASD? Do. So yeah, over here, this parse. This is trying to work right now, right? Tracing. Info value is value. Target is target. Tracing info compiled impl. Then we evaluate the impl. Let's see where I actually go wrong. So I have compiled it, but I could not evaluate it, right? Okay. Value is type into the 2. Filed is that. This is my impl type. Impl type be that. Why am I not activating my Linux? I am broke. I don't have money. No one is helping me with my situation here. So, you know, I don't know what I can do. Why some methods are blue and some are purple? Which methods are purple? I think purple is keyword and blue is the methods. Dot await, for example. Await is a keyword. This is not a method. That's a special syntax. Do you not have a sync await in Ruby? I guess you don't. So I don't remember. Neovide? Yeah, it's Neovide. Quick question. When you just started programming, did you find it boring at the beginning? I love tech and I found coding interesting for the majority of my life, but I never learned it because it's too sterile for you. Am I not the right guy to learn code, or do I just have to push? Maybe because I'm a gamer and my brain is used to constant stimulation, which coding does not provide. I don't know. I mean, when I started coding, I started coding because I liked games. So I wanted to make games that are better, maybe, or I don't know, something. So I wanted to make games. Making games is not boring, I think. Even though there are boring parts, but I don't know. I don't know, like, you know, it's like when you play a game, playing a game can also be boring, no? Like, let's say that you're playing something like Minecraft. Sometimes you just need to dig a tunnel, which is 10,000 blocks long, you know? Is that boring? But, like, then in the end, you get the result. You get to enjoy your new tunnel, which is long and deep and everything, right? If coding doesn't provide stimulation, then you're coding the wrong things. Yeah, I guess that's right. think about why do you code, right? What do you want to get as a result? I think whenever I'm bored of something, it's because I don't know, like, why am I doing it? That's when I'm getting bored. With a chain of 6 methods, half are pale blue and half are bright. Line 1255. Because this is not a methods, this is field, this is field, this is method, this is method. This is keyword. Wait, await is keyword. This yellow thing is a module. This like a little darker yellow is the variant. Okay, impl type is this. So the implementation type was correctly figured out. But then when I evaluate it, I don't get that type. So when I evaluate this, I don't get that type. Okay. So no useful information from this. So it's the evaluation that is wrong. And the thing is, when I am evaluating here, native, the actual type. Language should be simple, have less colors. I don't agree. Why? How is less colors simple? You can okay, so the simplest language with only 2 colors is black and white color for 0 and 1, and you just write binary code of your like executable by writing 0 or 1. Is that a simple language? I mean, it is. Is it a simple language to use? No. So I don't agree with like the ideas of simple languages at all. So yeah, it has evaluated it into the not inferred type. What? The best language is .txt. No, it's not. Because when you're writing text, how like the reason it's not is because it's hard to maintain when you're, because you need to remember in your head when you want to like maintain your project like that. When you change one thing, you need to change it in other places, and those other places you need to remember about. Remembering is the hard part, because there's too much stuff to remember when your project is big. You need the compiler to take care of it all. Brain small. Yeah, my brain is too small. I don't know. Maybe other people have no trouble, but I don't think so. But yeah, right now I actually have a small brain moment where I like my bug is somewhere right in front of my eyes and I don't see it. You forget stuff very fast. Maybe you should stop watching streams. I don't know, maybe you stop distracting yourself so that you can like focus on remembering things. It's a joke. It's a joke. You can continue watching. It's fine. You can just write things down, I guess. At least as a to-do comment. Dun, 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 dun. How about I evaluate? Can I say something like tracing info, evaluating expression short, and then tracing info as expression data type? So that I want to know what are the expressions that I'm trying to evaluate and what am I trying to evaluate them to. Right? So so the native parse expression not inferred. No, hold on. I was evaluating const expression as string as line 38. stdlib 38. So this parse was evaluated to a string. Sure. I was evaluating native expression as not inferred. Yeah, native parse is not inferred. So like, why is that? Because when I was evaluating tuple expression, this type over here is correct. So I'm not elaborating my types for the field expressions, right? And why not? And why not? Because it is not being made the same, I think. Okay, I think I understand. I think I understand. Let's see here. Function init. Over here, when I say have a tuple. So this thing, since this is a default, yeah, it's a default. And then I override the default because I say that this type should be same as like something else. We completely forget about the default, and the default is where I specify the types of fields here and associated them. That's why I was writing this check. All right. Yeah. So I want to say that if okay, I'm going to match inferred, and if it was inferred type type, then all the fields must be types, right? Then all the fields must be types. Tuple. For name field in tuple as a ref. Field data type expect infer to be type. Right? Mail tuple inferred to be inferred question mark, because it's only supposed to be inferred as tuple, or argument requires that tuple is borrowed for static. Yeah, let's clone it in that tuple will clone. So I need to move it here, right? Yep. I don't need names. Consider removing the into because expect inferred. Yeah, sure. So if it was inferred into a tuple, and then tuple inferred, then I say that for, can I zip? I can zip. All right, so we do tuple as ref zip with inferred, right? So, and then I say for name and expression and inferred, I don't know, original inferred. This I say original. This is supposed to be what? Original data type. Make same as inferred. What is inferred here? Known. Why is everything unknown? This is not right. Type. These are supposed to be types. Mismatch types, expected, tuple, found tuple. Wait, what do you mean? The zip? Expected tuple? Because inferred is a tuple type? I need this as a ref, I guess. Right? Mismatch types, expected, struct, tuple. Found tuple. Wait, where? Where exactly? This is an iterator with items of type tuple. Wait, what? No, it's not. You're lying to me. Tuple. This is a tuple of expressions, right? Tuple of this. This is result. Tuple. This is an iterator of with items of type tuple. Oh, okay. Hold on. Wait. No. Because it's a result. Yeah, because this thing can fail. This thing can fail. So I need a question mark here. Make same question mark. Inferred. Oh. Okay. It's a little weird when the result implements the iterator, I guess. Wait, does the result actually implement iterator in Rust? I understand it for option, but what about the result? What would it do even there? It like only iterates over if it's okay, or what? I never needed that. So result implements into iterator. What's the item then? Item is T. Is anyone who is writing Rust ever needed this impl? Why is into iterator implemented for a result? I don't get it. Rust result as iterator. Why? I don't know. That sounds like an easy. You use the one for option makes sense to me, right? Because option is basically like a list of 0 or 1 elements. But if in case you turn a result into an iterator, then you're going to silently ignore the error, which seems like a really big problem for me. But I don't know. Mm, tracing info running tuple check. Tracing info tuple check. Done. Do that. A running tuple check. Okay, so it's the same thing. So for some reason, I cannot go and do this for some reason. So what is running forever? What is running forever? Maybe in the inference, I have the variable with the incorrect state. Is that possible? Maybe, like get root maybe. Let's see. Tracing info 1. This might be the thing. Oh, it's not the thing. Make same. Inferable make same. For type 0 make same. Tracing info making same. Making same, sure. Making same. Tracing info made same. Okay, so this is never returning. Why is this never returning? Because the inferred things make same. Make same. Is it because I'm running checks or something? Run checks. Run checks. Let's do here. Tracing info. Running checks. Done with checks. Running checks. Running tuple check. Yes, okay. Yeah, I'm running tuple check. Running tuple check over here. So this is not working. Why? Tracing info. Doing aim. Tracing info. Huh? I don't know, where am I going here? Name is option string, yeah. Guess I just do debug. Doing some name. Okay. Wait a second. What is the thing that has a name? This thing has a name. So this cannot work for some reason. And then we say type make same. Type make same type tracing info, make same inferred type. Is that where I'm going? Wait, hold on. It's not even where I'm going. Wait, what? So I'm going into make same type. I'm saying make same. All right. I'm somewhere inside here, I guess. Is this code breaking? Tracing info mid. So I'm not getting here. Am I getting here? I'm not getting here. Start. I am definitely getting there, right? Because that's the thing that I'm calling. Yeah, I am. Okay. So it is the get root over here that does not work. Okay, that's impossible. Okay, this means that I have a bug in my inference stuff for sure. Yeah. So get root is just I'm either getting closer to root or not, right? Oh, I think I see. No, I don't see. Well, first of all, since I did the get here, I forgot to set it because I'm supposed to update it here. I'm supposed to update this here. Return result and then say that this dot set this value that I have mutated. That's probably, that doesn't matter because this is just improves the speed, I think. Closer to root is root clone, and I get that there. Tracing info, get root. Get root done. Get root is never done. Wait a second. Get root. Why? Is because like get tracing. Hmm? Is it because of mutexes that it's probably a deadlock actually. This probably is a deadlock because get I'm locking the entire state while previously I was only locking a single thing. So the reason is, I think, that over here when I'm doing the modify, I'm pretty sure it's like because of the modify. Right, get our default. Yeah, we run the checks there. Yeah, I'm pretty sure that's the thing. So over here, I'm calling the function on the locked state, and then while calling that function, I might want to do that again. So yeah, I guess I just want to do self set function from mutable self get. I guess for now, this is going to be good enough. I could do like individual locks for every single variable. Have a global lock. Let mute value is self get. And I say that let result be f value, and then I say self set value because I have mutated it, and return result. F mute value, yeah. All right, nice. So now the entire standard library expected to be of type unit, but I got not unit. Wait, why is the entire thing expected of type to be of type unit? That makes no sense. std.lib import failed. Like, okay. Wait, why? What? That makes no sense. So that's just another bug, but other things have worked. Okay, let's fix that too. So why is that? It's because the expression, which is a recursive expression, recursive expression data is of type unit. Yeah. But the type of itself is a tuple with fields, where fields is where I'm collecting the bindings. Am I not collecting the bindings properly during compilation? Expression expected to be of type this. Is this an empty tuple or is this a unit? I would like to know. Hello Xent, how are you doing? How's programming going today? Today is not very good. Today is a cursed day. I don't know what's wrong today exactly. But I mean, the project becomes bigger, it becomes more complicated and everything, you know? It's fine, it's fine. Progress is still being made. Let me do here, tracing info, recursive fields is fields. Can I show it? Yeah, this is it. The fields are empty. That is wrong. And that is wrong because collect bindings is wrong, right? So collect bindings for the body. The binding is this. Expression. I collect everything from the list. And then I only do it if it is not const let. Okay, I see. Wait a second. Why is this if even here? Why is this if even here? Anyone knows? Is it breaking anything if I get rid of it? Okay, so now I expect it to have syntax to be syntax module, type being type, and everything. But I got this thing. Is it just I have the different... No. Wait a second. Float 64. Panic. I think it's over here is because the order is different. So like for my tuples, the order is important. Right? But should it be important? Maybe it should not be important. Right? So type equal Well, I guess it's just for the tuple. When the tuples are equal, I guess the order doesn't matter. Does it? By hash. I think the order should not matter. We have the named order, and this is just for me showing things. But in order for comparing things, I need to have like sorted order, probably. Name, yeah, sorted order. String, and I should use the sorted order for, I guess, sorted order. Well, I mean, I have the binary string map there already, so like I have the sorted order already. Named order. I'm using this for hashing. So like for hashing, I should only use the yeah. I should just go for name and value in self-named. I guess the order does not matter for equality, right? Think. Is equality derived here? It is derived. Okay, let's not derive it. Hash. I think even the normal hash should not be derived. Since the equality and hash should agree. This doesn't do anything. This is different function. Hash. Sure. Yeah, and then I implement partial ec and ec. So if self unnamed length is not equal to other unnamed length, and false. If self named is, can I compare iterators directly like that? No, we cannot. Okay, can I wait? Can I compare the iterators for equality though? Rust compare Rust ec for iterator. Maybe in iter tools or something. Does Rust have only one method for equality check? I mean, equality check is the one thing, right? I mean, it depends. For example, for reference counted things, there is a separate method which is called pointer equality, in which case you compare the pointer, not the contents. But I guess that's the alternative of like the things like Yeah, after things like in Ruby, because in Ruby everything is like by reference by default. So like one of those are comparing references, one of those are comparing the actual values. So yeah, technically we have that, but the normal equal sign is like structural equality, I guess. No, I mean it's the like like you give it your meaning. I guess it's a trait. This is a trait for comparison using the equality operator. Is there like any? Whatever. Okay, Nerdsel, do you not know the method for comparing equality? There is CMP with iterator. Wait, hold on. CMP. If there is a CMP, then there is also a method ec. Okay, there is literally determines if the elements of this iterator are equal to those of another. Okay, what if the two iterators are of different sizes? Though determinants are equal to those with respect to the specified equality function. Yeah. Well, I'm assuming that like it should be having the same or amount of items, right? Doesn't say in the documentation really. Like the zipping of the iterators can fail if can like is going to silently ignore some of the items if the one iterator is shorter. I'm welcome, thank you. Thank you for helping me. Iter compare. Compares two iterators element-wise using the given function. If control flow continues, the return for the function comparison moves on to the next element of both iterators. If one of the iterators runs out of elements, control flow continue ORed is returned, while ORed is the result of comparing the lengths of the iterators. Okay. Makes sense. Makes sense. Okay. So it does check the lengths. All right, nice. So can I just say named keys equals to other named keys then, right? That's how we do it. Well, I guess they could not do this with just the normal equality operator, and they do it with a method. So I guess there you go, Belik. See, like this is different, right? This is equality with operator, and this is a method. Why did they not do it with the operator though? Because this is a generic iterator, I guess. Yeah. Sure. Because of orphan rules or something, maybe. So if I guess not equal, then that is what I want. Return false. Right? And actually, I just want to check. I'm just going to iterate. And I'm just going to iterate, right? Yeah. So technically, it is self-named, self-unnamed is equal to other unnamed, and self-named. Wait, but I can just make equality, right? That's literally all I need to do. And then the order we ignore. There we go. Why was I trying to do it that complex? There we go. Simple t ec for tuple t. Okay, nice. It's working. Okay, tracing info. I'm going to remove these things. Trace. Remove. Ending with Ali. Hello. Welcome. Thank you for the raid. How are you doing? Was having a hard time with my code. It was not working. But now you joined and it's always working again. That's nice. What were you doing on your stream? I just had a little bit of a deadlock moment where I deadlocked my code and yeah. Just a casual light bulb botnet getting modded. Wait, yeah, you're getting modded. How do I prevent you from being modded though? I mean, I see your messages, but I guess the other chat is not seeing your messages. You found it? Works now, yeah. Did you do some like allow or what? Unrestrict username, I guess, right? Yeah, there you go. Found it. All right. I'm working on a programming language and wait a second. Is it breaking again? Something is breaking again. Expression expected of v type, but we got binding t. And not inferred. It's binding t. It's supposed to be a type. Which one? Name self ID 69. Nice. It says steady leap 34. 34 over here. So this self was expected to be type, but it was instead and not inferred. Yeah, I'm making language. I don't know if I can show you something. I have some errors here, but maybe something still works. std print. Hello? Ali? And there you go. This works. But the thing that was not working is this thing. Well, maybe it still is working. Let me see. std parse 123 std int 32. Template is not compiled yet. Okay, yeah. So like, template is not compiled yet because I need this to be compiled, and the reason it was not compiled because for some reason this was evaluated to unknown type. But I said that it should be a type. Right? Right. So why is it a binding T of type not inferred? Wait, hold on. It's a binding T of type not inferred. Oh, binding T. Because this T. Okay, it's because this T is not inferred. Okay. I see. I think I know why. I think I know why, because this is introducing a new binding. And the type of this should be the same as the type of the template here, right? So when I say T as parse, I should like assign some types here. So the problem here is that this type was not inferred to be type. This should be type. If I do this manually, I think, then I no longer have an issue. std parse 123 std int 32. Okay. That did not work, because once again, expression expected of type parse string into binding T, but we got a string into int 32. Okay, yeah, I understand. So this though is correct. This is correct, because the thing that I was expecting to see should be substituted. Interpreter here expected to be of type this. Yeah, so like expected type, right? Expected type. So expected type is self-substitute type bindings of the expression data type. I guess this can be done even like in the very beginning. Like over here. Substitute. Maybe I don't need to substitute it anywhere else, because like this. That's a little different. The actual type, like over here though, this is the same expected type. And that's it. Okay, I guess it doesn't matter then. Let's see again. std parse 123 into std int32. So now this is a generic function. It needs to determine what type to parse it into. So this is technically a more like the more verbose version of this is doing this with underscore. So this is supposed to be inferred, the generic argument to this function, right? And this has been inferred based on the result type. So it's same as like let x be of type int32 be std parse 123, right? That will make sure that it's done. If I change it to be anything else, then it's going to be this different type. But yeah. Did I make it all work? I think the unit is a little different. Data type inferred. This or error. Wait, what? This cannot be an error. Inferred or default. This cannot be an error. Error. Mechanic unit not inferred. Okay, so what's the problem with the unit? Because it's just not inferred. There you go. Here we have a to do. So this should not be not inferred. This should be new, not inferred, but with default, and the default should be unit value and not unit type. There you go. That to do can go. Nice. Unless it breaks something here. Doesn't. Good. Okay, is const let is unused variable. I guess I can remove it then. I don't know why I need it here. If I don't need it, I should remove it. I mean, okay, you know what? Let's skip it. Is const let. Maybe I will need it later. I also am thinking that const let, like, instead of const, like const x be 1 to 3, because what is a constant? A constant is just a value that's known at compile time, right? I think I will have a comp time, or like maybe, I don't know what it will be like, but I think maybe comp time or const. But yeah, so I can do comp time and then like evaluate anything like 2 plus 2 at compile time, right? Like this. This would evaluate it at compile time instead of at runtime. And like similarly to that, a comp time let would just make a constant, right? So I don't need a dedicated const expression for this, I think. We'll see. Right? Because like const is just running the let at compile time instead of running it at runtime. That's all it's doing. Should I test something? Like I did things. Most importantly, I did that like if I use std star, I can do like int32 and string. So if I just evaluate this is going to be a tuple of type int32 and a type string, and the type of this expression is a tuple of two types. But now I should be able to specify that this is a type, and this is automatically going to be a type, which is a tuple of int32 and string, right? Nice. This took a little more time than I expected it to take, but it works. It works. And also I have the default for numbers. Number literal type could not be inferred. No way. Wait, what? Number literal type could not be inferred. Wait, what? 2 plus 2 does not work? No way. Wait, 2 works. Okay. Wait a second. Wait a second. Number literal type could not be inferred. Oh, wait a second. I know why. I know why this does not work. So you know how I have default values for my inference variables, right? But when I unify two inference variables, the default may be forgotten. That's the reason, right? So when I say that two variables are equal, I try to like unify their values, but I'm not trying to unify their defaults. Wait, what if like there is two things and one is defaulting to one thing and another thing is defaulting to another thing? I think we should just reset the default in that case. Like, you know, if I try to do something like something like 2 plus 2.5, like, and then I had the logic where like this would be defaulted to I don't know, but this would be defaulted to integer, and this would be defaulting to, how does it work in Rust? Let me see, play Rust lang org function main, let x be 2 plus 2.2. Cannot add a float and an integer. Okay. All right. I mean, it is going to work differently for me. I do not have integers and float types, which are like abstract integer and abstract float type. I don't want that, I think. Let's also see this. Common default value is if common value is some, then none. Because I don't need the default anymore, right? Otherwise, I will say root default value. Okay, match root default. I mean, if the default values are the same though, right? Match root default value and other root default value. It's none, 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 none. Some value, some value, some value, some value. Okay. If it's some A and some B, then I will say A T make same A A and B dot okay. I think if this fails, then like it's fine. I should not fail the entire thing. A clone, B clone. I mean, take from here, take from there. I guess I do not clone. Dot map arc new. No way you can waste points now? Yeah. Straight from T. Found this. Alright, T clone A. That's why it's written like that? Yeah, that's why. T clone B. Okay, so common default value is here, and I say that other root dot default value is common default value. And over here I say root default value. Okay, let's try again. So now 2 plus 2 should work, not only just 2, right? 2 plus 2 is 4. Nice. Isn't this the perfect redeem? It is. 6 plus 9. 15. Nice. Okay. So this defaults to int 32. I guess next time I will go and implement the context system so that I will be able to like configure the default number and shit. And a lot like context system is a lot of things, so yeah. And then we also need unwinding and continuations, and I think it's almost usable. And then I mean, then we're going to like spend 1,000 years fixing all the bugs that I probably still have, right? We can do the math. I think I only added the addition and subtraction. Let me run the tests too. Okay, the tests failed. Okay, some tests succeeded. Fibonacci failed. Let's try Fibonacci. What's wrong with that? Oh yeah, also like this, const parse. All right, let me fix some more things before I finish. Progress. Default values for inference parse. Okay, if I remove this type here, this is going to say that this is not inferred. So the reason it's not inferred is because I did not say something. Let's see, type, compiler, kast. When I'm doing the kast, I'm evaluating target to none, but I should not evaluate the target to... Wait, no. Target is evaluatable to none, yeah. But value should be this. Maybe when I'm initializing it. Yeah, when I'm initializing it. Expression data type should be cast result type. Of evaluating the value. So yeah, over here, since I'm evaluating, maybe when I'm evaluating the value here, cast scope evaluate value. Value is expression. Cast result type value. Like I need to make sure that the argument, right? I think it's mostly when I'm calling a function, right? Yeah, I think it's always when I'm calling, whenever I'm calling a function, the type of the argument should be the same as the type of the function arguments, right? I'm not checking it here, but I should check and assert it, right? So we are compiling the function, and then I'm going to say that argument type makes same as compiled argument data type, right? Is that all that I need to do? Looks like it. std parse. So now more inference. Wait, what happens if I do std parse 1, 2, 3 plus 5, right? Because this 5 is going to be inferred to default to std int 32, right? Which means that this is going to infer that I should parse an int 32. So I don't need to even specify any types here, right? No, that's wrong. But if I specify the type, then it works. Wait, okay, so I have this problem somewhere else then still. Type is not inferred, failed to hash. Was evaluating field, instantiate, call. What do we do? 5 plus parse? I don't think it should matter. I mean, let's see, 2 plus... Okay, wait, hold on, it works. Wait, what's the difference? Why did you ask this? Why would that work and that doesn't not work? Huh? How did you figure that out? So the addition is for all t, left-hand side and right-hand side of both t. So like those are like, I mean, it doesn't matter. By the way, technically, I still right now like say that this should work, but this compiles but doesn't run right now. I need to make this a compilation error. To do where t something I have one directional default propagation or whatever. I'm pretty like I mean if I didn't do it, if I did it correctly here, then it should be the same. I have two variables and I unify them. I say that these two things need to be the same. So this is an inference variable and I say make same, right? One inference variable should be the same as the other inference variable. So the first one might already have some default and the other one might already have some default, right? So what I'm saying is that if none had default, then no default for the unified value, right? And if one of them had, then yeah. If both of them had the default, then it's something else. It is, I don't know. This is weird. Let me see the something else first. Just run, or I guess REPL examples. No, not the monad, Fibonacci. Because Fibonacci did not work because so we expected to have Fibonacci, but we also got the print and parse and everything. Oh shit, okay. So I got everything re-exported from the standard library. And it did not check because of that. Use. I think I might change the way I'm doing this thing. I don't know. But at the same time, not really. So here's the problem. When I have something and I say use std star, this brings all the items from the standard library into the current scope, which means that the result of this entire file is a structure that contains everything from standard library plus the Fibonacci, right? But when I'm determining the type of this, I only see that I am declaring Fibonacci, and I don't see what I like. This is not being exported at compile time. Compiler, use, namespace, is expression. I think I should just not check some things, actually. When I'm doing the interpretation, like over here, result type is not equal to expected type. But I think some things I should not even check. That should check result type is match expression. All right, let's see. I have something with the dot dot. Dot dot dot. Dot. All right, let's do this. I go to opening bracket, the percent, like that. Not all of these have named field, I think, though, or do they? Actually, no. They all have the named fields. So yeah, never mind. I think I can just do 5 macros. 4 macros. All right, nice. So instead of a to do here, I think all of that is going to be changed to the vertical bar. So we say true, right? But some of these I'm going to change to false, specifically the recursive. But maybe I will like make it a to do. To do. All right. I'm just going to ignore this for now. So if check result type and it's not equal, then we do an error. So now I can go into the Fibonacci again. Fibonacci 10, 89. Okay. I can feel that it's not being evaluated immediately, by the way, anymore. I think I'm gonna have a little bit of a performance issue when I'm going to actually start using this thing. Let's run other tests. Okay, there is variant types that has failed because it has overflowed the stack. Okay. Wait, hold on. Fibonacci overflowed the stack. Oh no, I'm overflowing the stacks again. How am I overflowing the stack? And what is being done recursively then? Is it in the inference? Where would it be? I think get root might be the problem, but I'm not sure. This over here is recursive. I can change this to be iterative. That on it. How to debug this stuff? No. Looks like this is actually not it. Mm. Let's see the variant types first because they failed. This failed because this example does unwrap on .error. Panic that tests example 103. Assert this is going to panic. Oh wait, so this I did not panic or what? Hello there. Hello, hello. Hello, Nigel. How are you doing? While compiling built-in macro. Okay, I actually did not compile something. Okay. Hi. That makes sense. Let's see. Just run examples of variant types. Okay, this is not a type. Yeah. Okay, hold on. Wait, what? stdlib23. stdlib23. Because OK is not a type. New type. Okay, okay. I think I might not be specifying that this is a type. Is that right? Expected nothing got type. Okay. And the variant types. So I guess it's about this thing where OK is a unit, right? Can I say OK is a unit, which is a type? Okay, nice. So that works. So like over here, this for some reason failed to infer that this is a type. First you thought that I am wearing a bathrobe? Oh, hello Dev Ninja, by the way. Did you see that? I'm running tests and now my code is failing. Imagine if I did not have tests. My code would be working then. I blame you for making me write tests. The only test Scooby makes is when he's testing my patience? Huh? What? Okay, so I need to make sure that the arguments to the template's instantiation is the same as the arguments of the template itself, right? And I'm not doing that. Okay. Okay. Instance compiler. Instantiate argument to do. Why am I cloning? Why val when I should be value? True. Oh, but I have the template type, right? Before evaluating this, I should set its type though. Okay. Sure. See. Argument data type make same as template type. Wait, what is template type? This thing. let template type is kast await compiled. A template type is a compiled function. Template. Because this gives me maybe compiled function. But a template is a maybe compiled function for the type. Okay, sure. All right, I will not question this. Am I evaluating this first? How about I evaluate this after I get the compiled thing? I'm not sure if it's going to break something, but I think it should not. Compiled argument data type. Clone. Question mark. Is that it? This is not a type, a standard library 23. On the result, unit is not type. Oh, so I know that this is expected to be a type, right? So hold on a second. Let's go into a REPL. Just REPL. So if I say option nothing, right? This is not a type. There we go. So this is already a problem. Because option of unit should work, obviously. What does I say option dot x is int 32? Then this is not a type. All right. But why? But why? Because I'm instantiating it, so the type should be the same. Tracing inform, compiled, arg data type. Whenever I'm compiling something that is instantiated, option is not found, std. So compile, okay, this is not inferred. So the problem, I guess the real problem here is that this is not inferred. So because that is not inferred, it's defaulting to to just evaluation of that stuff. So why is this? Because new type maybe is not specifying that the arguments should be types. If I say that this is type, std option. Now this works. Okay, nice. Okay, so I need this to be inferred, which means that new type is not setting that the variant arguments must be types, right? I guess is what is happening. So new type. Over here. Yeah. So like all I'm doing here is that the new type is expected to be a type, right? But what I should also do is that everything inside should be type. When I have a multiset, I think I just need more stuff to work here because my multiset is like, if I break down the definition of the variant types, right? Sum t. So this is me constructing a variant, sum of t, right? But this needs to be something. Okay, I think I just need more stuff here. So I will specify the types here manually because this cannot be inferred, I guess. So I need to specify all of these. Type. Error dot equal error. I can make this shorter, I guess, easily. Steady result. Okay is nothing. Error is nothing. Okay, so this works. If I do cargo test, the variant types have succeeded, but Fibonacci still overflows the stack. Okay, what if I just test Fibonacci 5, not Fibonacci 10? Because that's a much... Okay, then it works. Okay. I mean, 10 is not a very big depth, though, right? For recursion. So, I don't know. What if I try... so I know that for tests, the stack size is different. The fib, you should name it RIP. Just REPL. Fib. And like I can calculate it here. I do notice that it's running slower than before, so I definitely did something. So like this works, but yeah, when you do cargo test, Rust spawns each test on its own thread, and the thread size for everything other than the main thread is relatively small. But yeah. I'm just going to ignore that for now. And I'm going to go rest because it's a little late for me now. I will write a to do in this standard library here. To do colon type should be inferred. Okay. All right. Progress. I think that's going to be it. I need to stop at some point. Where should you go then? All right, I don't know. Let's see where we should go. I mean, I'm going to go eat. I mean, over here. Do you know Bad Cop? Bad Cop is also writing Rust. We all love Rust, right?
We've got a dev container folder.
So, let's go
Also
there.
fun.
See you guys next time. Thanks for watching. Bye.
Whoa.
You want to see compiler stuff? I don't know if anyone else is doing
This
compiler
is probably
stuff.
not gonna work anymore. But I'll leave that alone for now, because that might be